very flat.
What's up, everybody? It is Wednesday, March 31st, last day of March 2021. This is Brandon, host of Brandon's Show. Hope everybody's doing good out there today. As many of you know, we did receive some data from Bob regarding some of the gyro experiments that were conducted a while back. And that has gotten everybody in quite the buzz. So we're going to try to make heads or tails of it this early stage of just looking at it and see if there's anything to learn from that and discuss that. That should be interesting, and we'll see what else happens. That might take up quite a bit of time. So we'll show you some of the analysis that's been done, and hopefully some people will, certain people join who understand the data and the tools and can help us make sense of it. So if you think you can help us make sense of it, you're free to join in the Discord. The address is in the description, and we'd be happy to have you. Now, what else am I supposed to say right now? Oh yeah, let me give you the link to the Streamlabs. All right, I'm a little distracted. The link to the Streamlabs, if you want to donate to the show, you can do it through this link. It cuts Google out of the middle, so that's much appreciated. Don't feed the beast. Or you can do it through super chats. It doesn't really matter, but all support is appreciated. And if you really want to support the show, come on into Discord. You can sit in there and listen, or you can join, be an active participant, and just ask that anybody that joins is respectful to the panel, tries not to interrupt too much, etc., etc. That's always nice. All of us have our moments, trust me. But come on in. And we do have quite a few people in the Discord already. So should be a good conversation to start off with. Let me say hello to who's in the chat first. To start off here, we've got Ian Adams, Mark Taylor, YouTube, page 42, Bill G. Thanks for the sound check, Bill. Mark Collard. What's up, Mark? Chrissy Heavey. Oreza Vitigan. I tried. Danny Burgess. Let's see here. You guys been busy. Second best Bob. C4. What's up, C4? And Bob is out there somewhere. I see signs of Bob. What's up, Bob? And Rob the Truth come in at the last minute. All right, let's get this show on the road. See what's happening. What's up, guys?
What up?
Hi, sweetheart.
Hey. All right, who do we got in here? We've got Boofus. What's up, Boofus? Face One, Aaron, Jeremy, Jedi, Jimbo, Kosho, Merle, RC Meisty, Sirok, Essie Montreal, Stacy B. What's up, guys? How's everybody doing today?
Going.
Hey, good evening,
Doing
Brandon.
good.
Respect, Brandon.
Hey, Brandon.
Good. So, I figured the big topic of discussion today, as you might have noticed from the thumbnail, would be the early looks that we've gotten at the data that Bob provided last night. Thank you, Bob. So why don't we start off with that? There has been some analysis. I haven't had a chance to do anything with it myself. The only thing I've seen is from Gem Server and the Ballers. So if any flat earther has done any analysis using the tools that Bob pointed out or anything else, I heard MATLAB was used in one case to create some of these charts. Happy to take a look at it. Doesn't really matter if it's flat earther, but thought it'd be good if we had both sides of the issue do the analysis. So that'd be cool. Did reach out to a couple people and ask them, hey, can you take a look at this? And I haven't heard much back yet. Hopefully they'll help us out there. Yeah, so what's going on? Jeremy, why don't you give us a rundown on what the discussion's been so far regarding that data from your perspective, since you were kind of the one who drove that through your persistence.
Well, first of all, I want to say thanks to Bob for giving us the data. That was good. We've looked at it a little bit, like Brandon said. It's not just from what the Globers have given us, but it seems like there's a direct correlation between the temperature and the gyro readings. He did get up to 18 degrees an hour, it looks like at some point. And, you know, as low as even, I think it was 11 or 12 degrees per hour at other points. What we don't know is the altitude at which the data points were taken, if this was all at the same altitude or what. So, I mean, there's still some questions on the table, but I mean, I don't know.
All right. Well, why don't I show one of these? Does anybody know who Fug XD is? Because that's the charts I saw.
Yeah,
earlier.
Yeah.
it's Fugix.
Altissimo.
It's Altissimo.
Yep.
No, that's Fugix.
No, apparently,
Yeah,
No,
apparently
No, I heard-
Altissimo did all
Two
this.
different people.
Oh, okay. Well, if Fujix is
yeah,
out there.
Fugix
he's
is
more-
the
I'm
one
not
who
saying
did
it's the
this.
same.
He just put it out on MATLAB. We just took the CSVs. I did the same thing last night. I put it in Jupyter Notebooks, and you get the exact same plot.
Who's that? RC.
Yeah.
All right. So you're familiar with the data. You got the same result as Fug XD. I guess we can use this chart to talk to, and maybe you can, since you have actually done the analysis, kind of tell us what we're looking at here, if you wouldn't mind. I should be
Sure.
sharing in the
So-
Discord too.
Sure. So if you see, Kosho posted it right here. The first one is the rotation rate, right? It's in degrees per hour, and that we see essentially a variation between the logging. So the different colors are the different loggings, right? The different logging sections. And then, so what it does is essentially just every few seconds or milliseconds, it will take a reading and it will give you a rate based on the interferometer at that time. What you see is that each of these times it had a different temperature. And so you can see the different loggings all clustered together at one given temperature, which would tell you that it was probably taken at one particular time. So if you look at, for example, like logging, like the yellow one on the very first one, so it's going to be a particular date and time. You can actually see the date and time stamp on the, or actually, no, that's not the date and time stamp. Never mind. That's just an identifier. And it's reading it from each one of the CSV lines. CSV is just a row and a column as it's stored. And basically what you can see is the clustering that happens at each of the degrees and the rotations per hour. When you see this small spread right here of the rotations per hour, the outliers are anything you can, when you're working with an interferometer, you can get like a little gust of wind, a bump on the table, like a fly landing on the thing can cause these big outliers. It is not a general reading. It is going to be like a little bump happens and you'll see these like little spikes in it, for example, right? Where you see like these really weird outliers. The second one's the most interesting one because you do the time in seconds and you can actually see some instances, for example, when someone like something happens where it was either bumped or, you know, something landed on it or a little piece of wind came by and a reading happened that was up to 20, right? But if you take it as a log of all of the, you know, instances for that particular reading, you'll see that it's definitely an outlier. It is not along the line that is average for that particular reading set.
You're talking
So
about like this
flies
data
and
point
bumping
here at what would this be? 1300 seconds and
Yeah.
and
There you
20
go.
degrees. You would consider this to be an outlier because it's way outside
Yeah.
the standard deviation
So,
of the
yep.
rest. Okay.
So due to
So what
flies
you
or
essentially-
bumping, let's get that straight now. These anomalies, you attribute them to a fly and somebody bumping the machine, correct?
No, I said it can be literally anything that is a perturbation in the interferometer reading that is not an average of what you see from all of the other consistent readings that are happening.
Sure. So
So
what?
in data science, when we see these outliers that are non-clustered outliers like this, we don't look at them as indicative of something as the whole data set. We look at it as an anomaly that happened outside of what the average is.
Fair enough.
And you
Now,
can see those as outliers.
fair enough. So let's understood. There may be outliers. We can quibble over that later. But in general, it looks like, so if I look at, say, logging we'll just call these by their colors. This blue one, the dark blue circles on the top. In general, those are all around, you could say the average is probably about 17 degrees for that data set. Then you've got these other circle data sets below it where they're hovering around, close to 16, 15 and 3/4. Then you've got all the way, same thing for these data sets. You can see how they're spread out generally around the same rotational rate on that axis, around the same area for each data set, all the way down to like these brown ones at the bottom. You can see they're all clustered around, say, 12.
Yep. And so the question that a data scientist will always ask when you see what we call an average distribution among data set collections like this, you ask, what is the variable in the data set that correlates with these normed lines or averages across each of the data loggings? So you see that, for example, the way to look at this is all of the blue ones are along about the same line. All of the yellow ones are about the same line. All the purple ones are along about the same line, right? The variation in the logging, except for the blue one, are all within right around 1 degree of each other, right? Which, again, we can quibble about, why might that be later, but the point is that they all show a consistent average. That will tell you something, because it means that now we can find a variable for which each of those loggings would be along one of those lines. And that's what Fugix did on the first one. He said, okay, let's find along the data set, where do these groups cluster? And they cluster along temperature.
Hey, does logging equal location where a data set was taken?
Logging is one set of
exactly.
readings that are taken.
You did it, 10 or 12 times, different sets.
There you go.
Where do you get the correlation between temperature and...
So again, what I was saying before is that what you look for when you see that there is an average along each of the data sets, but the data sets can vary, then you ask yourself, what is the variable along which each of these clusters vary? So you just do a basic regressive analysis and ask yourself which one of these does that in, and we were able to find the variable that it was, and Fugix found it right here and put it into a graph for us, which is it varies along temperature reading.
So RC, that makes sense. I understand what you're saying is that there's a correlation when you look at this temperature versus the rotational rate, which is this axis over here on the other chart, and you say, well, it looks like it's correlated to the temperature. Were those the only variables that were available in the data set, was rotation, temperature, and time, or were there other data sets that were in the sheet?
I don't remember off the top of my head. I've just looked up the thing again. They were very large data sets, and I don't have them open at the moment. I'm getting ready to go into a work call.
Sure.
But,
like pressure, for example.
There are a couple of other ones there too. Yeah.
Yeah. So I wonder.
Yeah, like
I wonder
pressure.
if there's altitude. I wonder if there is, pressure. I wonder if there's other data sets in there. So I think that's an open question, because I find this grouping that you have here very interesting. You have the 30 degrees. I guess this makes sense for them all to be grouped right around the same area. And then you've got this increase here, seems to span across the same. This spans across, say, 2 degrees Celsius. This spans across 2.5 degrees Celsius. But it's like 4 degrees of rotation difference here. And these are all clustered within 1 degree of rotation. So I guess we'd have to know a little bit more about the instrument's tolerances regarding how much of an impact temperature has on this. But this is just one data set that has been looked at, and I would like to know if there's
They
other
went
data
with
sets as
one
well.
variable, Brandon, and they ran.
Yeah.
They picked heat and...
Well, as far as
actually,
I know, no flat earther has yet to analyze this data set, including myself.
Can I say something? Why? Because there's plenty of people that will help donate anonymously and everything else for this cause. Why do we have either side doing it? Because we should have a professional paid for, give us the information, and therefore there is no arguing on either side.
I don't trust professionals. Sorry.
Well,
not doing that.
Here's the point. We all have access to the data. We all know, like, Bob gave us all access to the data. Anybody who knows how to either use Excel, Jupyter Notebooks, or he used MATLAB here can look at the data yourself, right? Like no one has to guess or argue about whether this is the true data, right? Well, I think
But they
Brandon,
have to be able to read it correctly and not run with its temperature or whatever.
well, Brandon said it correctly when he said we actually have to ask ourselves after we understand what are the correlative variables along these data lines, then we have to ask ourselves why does it correlate along those variables? What are the tolerances that each of the equipments we're using? Why does it, like, I would actually have no clue why it would vary along temperature, right? I would have to sit and actually understand. I would have to sit and understand what which is the interferometer that he's using, why would it be affected by temperature, all that kind of stuff.
Yeah, exactly.
Yeah, that was my thought.
My point exactly.
And is temperature correlated with something else, such as altitude, which is usually the case, especially when you're going up altitude quickly.
Yeah.
Yep.
Where is the altitude readings? He said he went to multiple altitudes. Where are those readings?
Well, that's what I don't know if that's in the data set or not. That's one of the questions I have.
Surely it is.
There's a pressure reading, as I understand. There's a pressure reading, but again, I would have to look at it. Look at the data set again.
And the pressure reading, I would guess, is probably also correlated with these temperature. I would bet you if we overlaid the pressure, there would be some correlation between that and this data set.
I bet you anything, yeah. And there's 20 different points, apparently. Yeah, not just one.
So let me just make it real clear. We're not drawing any conclusions here. This is not a silver bullet.
No, it doesn't say anything. Yeah. It's just the data.
Exactly. We're just looking at the data and trying to understand the data at this point. To be honest with you, I mean, I'll give you my opinion just as it kind of set the stage for where I'm coming from. Even if if we dug into this data and we decided, you know what, this thing does, when we account for all the variables and factor everything in, it puts out a reading of 15 degrees rotation an hour. My question would still be, what is the variable that is impacting the 15 degrees? We know something is moving. We know that we can see the sun, the stars, the moon, they're all moving. We know there are things that are moving in our system, and they're moving at 15 degrees an hour. The sun certainly is moving at 15 degrees an hour, even if it's rotating above us. So there are other hypotheses why this would register this 15-degree rotation, or why this device would give you the reading that it's giving you. So even looking at this data and deciding, yes, it does pick up some kind of reading which it interprets as 15 degrees an hour in rotation, what does that mean, and what is driving that data set?
Well, yeah.
Yeah, and not always 15.
And what is driving the variation.
And what's driving the variation.
The variation in it will actually help us understand a little bit better. So, for example, if it really was taken at different altitudes, which, like, you know, I would have to run the numbers again and look at that, you know, column within the data set of altitude, for example. I would ask, okay, well, like, do we have a density altitude on that, or is it just measuring pressure, right? You can actually calculate the density altitude of the air that it's going through using temperature and pressure if that reading is there. But if it's a GPS reading for altitude, then there's going to be a difference.
You know what I want to do? I want to put a mechanical gyroscope next to it. A good one. And I bet you there'll be absolutely no rotation on.
Well, I mean, mechanical gyros, you know, like gyro compasses, they rotate and they process with Earth rotation. Like, you know, we've seen gyro compasses for decades, and anybody can go look at a gyro compass on a ship.
But RC, you were saying if there's a reading for different altitude, but however, Bob said specifically last night that he had done this test at a different altitude and a different and the same latitude though. So how do you tell me that it's not in there? It should definitely be in there then.
Well, that's what I'm asking. I don't know. I have to look at the data after I'm done with work today. I have to look at the data and say, how did they actually log that? Was it a GPS altitude log, or was it a pressure altitude log?
Either way, like what Brandon was saying, it seems like it would probably correlate at some type of level to the temperature. Agree? Just
right now, yeah. The clustering shows us that there's a correlative relationship between.
And that's
they were saying there's.
That's exactly what I'm pointing out. Is that it seems like that if you take this first graph that we're looking at here, it shows that there is a difference depending on the altitude. If altitude equals differences in temperature, it does seem that it doesn't pick up just a 15-degree rotation, and it does pick up something like maybe an ether, where it's showing that at different altitudes it has different speeds.
Well, no, nobody well, this is the point I brought up with Bob last night, right? Like an interferometer is not built to pick up ether; it's built to pick up axial displacement. That's what it's built
So they
to
say,
do.
yeah, definitely.
So the temperature thing, they said
we calibrate the thing against axial rotation, or what you would say axial, like angular displacement. That's how we calibrate the thing. So
kind of like a mechanical gyroscope.
Hold up.
Right?
For example, we would not say like I have a voltmeter and I am using it to measure temperature. Like with those I do not calibrate voltmeters against temperatures, right? I calibrate them against a known voltage.
Right, but spin is spin, right?
Exactly.
If it spins under this gyroscope, it should spin under a mechanical gyroscope, correct?
Yes, and we see, I mean, that's an easy one because we see precession in mechanical gyroscopes on things like gyro compasses.
Not a gyro compass. I didn't say that.
Well,
I said a mechanical gyroscope should show something spinning underneath it, correct?
Well, it shows it being angularly displaced is how you say it. You don't say underneath something.
Well, say it any way you want. Put makeup on it. I'm correct in that, right?
Okay, no problem. Yeah, I'm not arguing with it. I'm just simply saying, like, go to any HDI or CDI in an airplane. Spin the gyro inside of it up and sit there on the tarmac for an hour. You'll watch the thing process.
Wait, let's be clear here. Now, when we talk about these devices, this is where I kind of get stuck in my head. So we're talking about a mechanical gyro. Let's say you watch it and it processes. What I'm watching is the mechanical gyro move. I'm still standing still. I'm watching the mechanical gyro. No, hold on.
No.
Oh, hold on.
No, bro.
Listen to me. I'm watching the mechanical gyro move, even if it processes, right? I'm not watching the Earth spin out from underneath the mechanical gyro. That is the claim that is being made.
Well, here's the thing. We know that the thing only
Brandon. It's the Earth spinning underneath it.
No, you're missing my point, SE. In reality, when I set it on my table, okay, and I'm looking at the gyroscope and I watch it, let's say it processes. What is happening before me? There's a gyroscope
because it keeps rigidity in space.
You're missing the whole point. When I am watching the gyroscope, what am I seeing happen before me?
You're seeing the gyroscope deviate.
I'm seeing the gyroscope deviate. I'm not seeing the fucking Earth rotate out from underneath the gyroscope.
That's an assumption.
That is an assumption. That is an assumption that people are making.
Or extrapolation is another way of saying that.
It's not an extrapolation.
It's a dramatic spin on the description.
I'm sorry. Why do you say that, Howard?
Communicating here, I think.
Yeah, I think you're missing the whole point, SE. To be honest with you, when you use a mount that tracks the stars, what is the mount doing?
I'm
Exactly.
not talking about a mount.
Just listen to me, God damn it! Just listen to me. You're thinking way past me. I'm talking in a literal sense. When you watch an EQ mount and it tracks a star, what is the EQ mount doing?
It's supposedly tracking the star moving?
No, I mean literally moving. What is it doing, Essie? It's moving. It is moving. The EQ mount is moving. Right? That's all that's all the phenomena that I have in front of me is the EQ mount moving to track a star I also see moving. Never do I witness the phenomena of the Earth rotating underneath something. Never.
So we're in agreement, brother. Okay.
Yeah, that's why I was getting pissed off at you, because you were thinking that I was saying
agreement. Yeah, okay. We're tracking now.
Yeah.
Never does the Earth move. Exactly, bro.
Of course.
All you see is the gyro move.
Saying that the thing that you're witnessing is either the deviation of a gyroscope or of a pendulum or whatever. You extrapolate or assume, in his case, is saying it, the rest of it. And this is truth. You extrapolate that it's the Earth rotating by seeing that. But that's only based.
No, you're dreaming.
only
That's
based
in
on
your
the fact
head.
that you try to
That's in your
isolate
head, Coach.
everything else.
Extrapolate is, I don't think, is the right word, because that seems
Yeah,
like
why is it
carry something
extrapolate?
out that is already partially started. You're making an assumption. I think that's a better word. You are assigning
No.
that effect that you're witnessing to a cause that you're not witnessing.
It would be an assumption if you were lazy about it, but if you were careful to make sure that it couldn't be anything else, then you would extrapolate that the thing that you already have other evidences for, like the stars moving, for instance, you could extrapolate that because those things are deviating at the same rate that the stars are moving, and you've isolated everything else from everything else. You could extrapolate that result.
So why did you decide to frame it as either my carefulness or my laziness?
I would say this assumption only based on laziness,
No.
because you could assume something, but if you've carefully, checked off the boxes to make sure it's not anything else, then I would say an assumption is the right way of saying that.
Right.
So you're saying you're eliminating all the external variables. That's what you're trying to do. But we think that you can't do that, right? Because we think there are other variables affecting it, and you think there aren't. So we're calling it an assumption. You're calling it extrapolation. Does that make sense?
I mean, if you want to do this test and you think there are other variables, you could then isolate from those ones. You can isolate
That's
from
what we're doing.
whatever other variables you think it is. Yeah.
Yep, we're in agreement.
All right. So it's interesting so far. Yeah, there was, geez, you guys were talking about it over in Gems for hours. Every time I popped in there, it seemed to be the subject of discussion.
But Brandon,
Yeah, we
I
went-
want to
we
make
went
sure
through
you
it today.
understand one thing,
How'd that
if I
go?
may.
It was exciting.
Did they claim, of course, that it has to be just 15 degree an hour and
The,
nothing
the
else?
the thing with the temperature is, they said there's a diode inside the
I knew they would.
inside
of course.
inside the.
Of course. Why wouldn't they? That's what I would come up with. If I wanted to make something up, that's what I would come up with. It's so easy. So easy to be a baller.
Brandon?
So there's a
Brandon, can I ask you a question?
Jeremy didn't finish the explanation.
Oh, I'm sorry.
He said the word diode.
That's fine. They said there's a diode inside the gyro that's temperature sensitive. So with different degrees of temperature, it fucks with the light somehow.
Of
I don't
course.
remember exactly how they
Of
phrased it. So.
Right. But you guys were looking at an impartial data set, as we've already discussed. You're not considering the other correlations. So how exactly is anybody coming to a conclusion? It sounds like, have you drawn a conclusion, Kosha?
I drew a conclusion before I'd seen this data.
Yeah.
But yeah, from looking at the data though specifically, I can make two conclusions based on that temperature thing. You could say that the variance in it is directly proportional to the temperature changes. So much so that the highs and the lows correspond with the highs and the lows on the rotation rate, and also the variance of the blue one on the rotation rate is correlative with the variance in the temperatures in the blue. So it tells you that because you can't change if something's not moving, the altitude alone is not going to change the temperature by that much. But whatever's changing the temperature by that much is at the same time making the data bounce around on the rotation rate. So I think I could settle on the temperature being the cause of the variance.
The altitude is not going to change the temperature that much. Do you know why there's snow on the top of mountains when it's nice in Denver?
That's not what I said. What I said was if the object's not moving, then it's not changing altitude. But in that blue one, the temperature is changing greatly by, looks like a span of 10 degrees Celsius from the high and low, maybe more than that. So there's something else that's causing that temperature to change. It's not just the altitude.
So yeah, we don't. That's another thing, that another piece of this pie that we obviously don't have is, what does each of these data sets represent? What is the experimental setup for each of these? Obviously, I mean, data, he just gave us the data, which is fine. But if we were really going to analyze this, we would need to know what the story is with these different data sets.
Yeah, of course. Yep.
So I don't know. Anybody else got any other thoughts on this? Does this blow anybody's mind or change anybody's mind about anything? Seeing this data?
This isn't as exciting as I thought it was going to be.
That's exactly what I thought it was
I'm
going to be.
Altitude and temperature are no brainers.
Yeah,
well, this
is
proves exactly
what I thought.
what Bob said. The variance
Yeah.
it shows
Yeah.
from 14 to 18, 20, like he
Yep.
said.
Just like he said.
Yep.
Changes in probably altitude. Yep, exactly. This matches perfect. This is exactly what I'd expect. It supports our theory as far as flat earthers, as far as I can tell. And unless the ballers are right about the whole diode issue, in which case then that could definitely, completely blow our theory out of the water.
Brendan,
We just gotta figure it out.
could I just have a second just to say something? Does anyone know what Bob's initial hypothesis for this was?
No.
Have the recording.
No.
Probably not.
I do.
I could take a guess, but
I don't think this would fall. I don't think this would fall under the scientific method, but
Yeah.
that's just my opinion.
That's kind of what I was alluding to when I was saying we have to assume what the cause is.
yeah, these are more just observations.
Yeah.
Is it just like he just got a ring laser gyro and just turned it on and
Yep,
saw what
just
would
started recording.
happen? Like just
Yep,
out of
exactly.
curiosity or something? Right.
Yeah, that's what he said.
I wasn't intimately involved with all that back then. I wasn't following it very closely, but I know that there was, like, it was a big deal for them to get this gyro. They were expensive, and, they were looking forward to getting it.
Sure.
But I don't know any of that backstory or, any of the experimental setup or any of that stuff. All we have is this data set.
Totally,
You know what I
yeah,
find funny? The mythical globe is supposed to be spinning at a constant rate, but yet here we have variations, like wild variations.
Do you think that these variations are due to these wildly different rates of rotation, or to the variables that can
Affected the device.
with any kind of testing device?
Exactly.
Well,
Yeah,
since I don't believe the Earth is spinning, I know the Earth is not rotating, so it's something else for sure. If you ask
Yep.
my belief.
This comes back to the old baller versus flat earther question. This doesn't seem to actually change much of anything, really, unless we can figure out the diode issue.
No, but it's
wouldn't
pretty
that be the first
damning
thing we need to figure out?
to the ball side, I must say, because there's variation here, and you guys, they say, well, we don't feel the Earth's movement because it's constant, but here we have a variation. Something's up here.
If you wanted to disprove that, or you could isolate that variable of temperature by leaving it in one location and running multiple tests at different temperatures in one location, or different altitudes at the same temperature, which I think would be more difficult.
That's what I'm saying. We have that.
That's what you.
Test. Yeah.
Oh, you do. You have that.
That's what I'm saying.
Yeah,
in that blue
that's
test,
the blue.
the blue test has a very wide temperature range throughout. Up to 10 degrees
On
about.
that blue test, how many
Yeah.
times was that tested in that data? How many times was there a difference?
It's like about
It was tested for
30
the same
different
amount of time. But if you look at the range of the highs and low from the rotation rate, the high and the low of the rotation rate is just about as spread out as the high and low in the temperature.
Whoa. Kosha, let's take a look at this data set here. You've got this clumping right around here that's from about 23.5 to 27.5 degrees. That's a large clumping, and it's all around the 17 degree rotation axis. What you're trying to do is pull in these four and this cluster down here, and saying that there's some kind of connection between those two. But what I see is most of them centered around the 17. So what are you saying?
Most of them are in that right side, but regardless of where most of them are, and any single one, like that blue one, it's super spread out. So the temperatures change greatly in that blue one. And if you look at the other graph, the one that shows the rotation rate, that's also the most spread out, especially towards the end. It's got lows of about just right under 15 to highs of about over 20, which is definitely the biggest range out of any of them.
So this one right here, this yellow one, what you're saying is that is that the one you're talking about?
No, the blue one is the
You're
one.
talking
the
about this blue
on the-
one, yeah. But then what I'm saying is, then you've got this, where it's different temperatures with the same. You've got a cluster that's different temperatures with the same rotation rate, and then you've got this
That's what I'm thinking.
smaller cluster actually than that one that is the same temperature with different rotation rates.
Well, yeah, but if you look at the blue one and the yellow one and the rotation rates, they're right about the same. They're like the difference between them is right about the same as the differences between their temperatures as well. Towards the end, they seem to be mixing and matching, but closer to the beginning, they're just right higher and lower as the other one. So I mean, I think it looks like it's directly related to the temperature.
I think you're stretching trying to draw any conclusions like that out of this blue data set.
Big time.
Especially since the temperature.
Well, can we
Especially
ask
since-
Bob, because Bob is here? Because I want to know how many times where, gyroscope was tested, like where he was at one latitude,
Oh,
right?
hey,
It's at
Bob.
the same latitude, but it was a different altitude. I want to know how many times it was tested at a different altitude for these readings.
What's up, Bob?
Hey, Bob.
Good evening,
Oh, he
Bob.
might be on mute.
Didn't Bob say we weren't allowed to ask him about the data?
Okay, can you hear me now?
If he
Shut
did,
up,
then I
Captain
apologize.
Buzzkill.
Okay, hi,
Yeah,
sweetheart.
We can hear you.
Okay, cool. Sorry, I'm trying to get my levels right. This and I have a kind of a flaky headset, so sorry about that. So, all right. Well, first of all, wow, what is that?
Left lane.
Sounds like a vacuum.
Left lane,
Hey, left lane.
your hot mic.
There you go.
Okay. So there were actually several sets done. One of them, of course, was done. The primary was done at Pikes Peak, Colorado, at an elevation of 14,125 feet, I believe. And then, of course, we went out on the plains directly east of that, on the same latitude line. And I don't remember exactly where that was. It was out in the country somewhere. And then we also did one at around Guanella Pass, which was around 10,000 feet. So basically, we had one that was nearly 10,000 foot variance, and the other one was somewhere around a 7,000 foot variance. And obviously, like I said, when we went down to the different elevations, we got a very, very dramatic corresponding change in rotational rate. Now, one thing I want you guys to understand, because somebody keeps saying it gets RC Micey. It's like, well, we're not doing anything with the ether here. I need you guys to understand why I am correlating this with the ether. And it goes back to a video that was done by Malcolm Bowden. All right. And this can also be verified through Einstein's writings and all this stuff. But basically, it goes back to Sanyak's experiment, which was actually looking for the ether, right? And you have that, and then you have the experiment done Michelson-Gale, which also picked up a 15 degree per hour rotation. Okay, so when you look at the way that Malcolm Bowden presents it, basically you see one of two things. If there is no such thing as the ether, okay, then, oh shit, hang on a second. My stupid phone's ringing. I'll be right back.
Sure thing. All right, since we have Bob here, I would just ask the rest of the panel, let's please not turn this into a shit show and focus on the data.
Definitely.
I don't want to get into any attacks of character or why didn't you give us the data earlier, any of that shit. Let's just focus on the data.
Please, let's not attack our own.
I'm not saying anybody's
Good
going
job.
to do that. I'm just pleading with you. But
That was Brandon's nice way. That was Brandon's nice way of saying "shut the fuck up."
Wasn't it?
Yeah, I'm turning
I
a
hear
new
you,
leaf.
Brandon.
Well, Brandon, could you at least bring Bob back to the first principles and why he might have even done this experiment in the first place?
Yeah, we can definitely
that's
ask
what
him.
We're going to hear him kind of go into the Sagnac stuff and the ether.
Well, let's hear what he
But
has
it's
to say,
kind
and then I think that's a
a lot
fair
of
question to
avoidance
ask,
there.
Merle. Is what why? What were you setting out to do? What was your?
Did anybody else
intention?
catch what he said? I wrote down Pikes Peak
Okay,
14,000.
I'm back.
Oh, okay. There you
Well,
go.
Could
really
I
quick, did you
ask?
say?
No, not yet.
Did you say
Merle.
the three different Did you say the three different altitudes were 14,000, 10,000, and 7,000?
Yeah, let me think about this. Yeah, let's see. Guanella Pass was around 10,000 something. Of course, you can look that up, but it was definitely done at Guanella Pass. And then Pikes Peak, and then we just picked one of the lowest altitude places that we could find on the exact same latitude line going out into eastern Colorado, which gave us, like I said, a very nice, huge variance in altitude. So anyway, as you guys can see, I posted in the Sagnac experiment in there. And one of the things that he talks about, of course, is that in Einstein's relativity theory, light will be the same speed regardless of anything. I'm sorry, it's not light will be, that's backwards. Einstein said that light will be, in other words, if you're going 1,000 miles an hour and you click on a light, then the relativity says that it will be going 1,000 miles an hour plus that speed of light. Whereas the Sagnac, and if there is an ether, which is governing the rate of inductance, remember, and that's what we're talking about, the ether. Light, we're saying that light is not a speed, it's a rate of inductance into the ether, and that rate of inductance is fairly consistent, all right? So that's one of the first things that I want everybody to understand, is to watch that video to understand what is going on there and why we're making this conclusion, or why I have been saying all this time that we are actually seeing this effect caused by the movement of the medium, all right? And when you understand that, I think that will help us a lot, all right, and going forward, all right? So I just wanted to say that.
But that's not really science, is it, Bob?
Well, whether it's science or not, it's observations. And, sometimes you have to extrapolate, because sometimes we can't always vary the independent variable and things like that. Sometimes you simply have to make observations and extrapolations. But you can also a lot of times eliminate or add evidence to an assumption, right? And that's all I've ever said we've been doing here, right? Is we are looking for a preponderance of evidence, because there are some things you simply cannot put through the scientific method. All right, it's as simple as that. So did science stop there? Does that stop science? No, it shouldn't. You should also then be able to, formulate other ideas and thoughts around observations that you can't necessarily put through the scientific method. And I don't think there's anything wrong with that.
Fair enough. Yeah, that's kind of how I was looking at it too, is these are observations. I definitely don't think it's a waste of time to do this. What was it you were setting out to try to figure out, Bob, and what do you think you learned from the observations that you did with the gyro compass, if anything?
Okay, well, first of all, I have to tell you that...
Excuse me, the ring
Rick
laser
Zimmerman,
gyro. Excuse me.
Okay, yeah, well, it's actually a fiber optic gyro is what it was. Right. This part right here that's showing the no ether relativity and ether classical, that's the specific part that everybody needs to pay attention to. It's the one playing on YouTube right now. Anyway, all right, so here was the deal behind this. I was under the impression, of course, this is long before I knew actually how the fiber optic gyro, and the technical operation of it would work. And I said on a Globebusters a long time ago, it's like, oh, wouldn't it be cool if we had a ring laser or fiber optic gyro, because those things are so sensitive, we would absolutely be able to tell if there was a movement or not, of course. And then, as I said on Behind the Curve, and I was just as surprised and honest, guys, and honest, that we detected roughly a 15 degree per hour rotation. I mean, it blew us away. We had no freaking idea what to think about that, right? So we started, coming up with all these different ideas and saying, well, maybe it's something to do with magnetic. Therefore, we tried to use the bismuth. We tried to use the zero Gauss chamber, right? And by the way, we did affect it rather dramatically with the zero Gauss chamber, but that's another story altogether. And so we were just simply trying to explain what it was that we were seeing. And that's when we came up with the idea, based basically on, the information that I had read before on the luminiferous ether, the way that it propagated, in this toroidal thing. And that is precisely the behavior that we found. Okay. So that, then to me, it was almost a no-brainer. Everything fell into place through those observations, and it correlated with, what the scientists of old, Tesla and all those guys, that Poncare, all those guys that Ken Wheeler talks about, basically that they had been talking about the ether behavior. It was a dead match all the way down the line. And so that is the conclusion that we came to. We could not come up with something that validated that we would get an absolute rotation rate of whatever Colorado's latitude was times 15 degrees per hour, because as you know, you can't just take 15 degrees per hour. It has to be it's 15 degrees an hour times the sign of the latitude. So it could vary, quite a bit, just from that. All right. But we extrapolated it out, and, in general, we're looking for that 15 degrees per hour. So that's what we were looking for. And that is simply as far as it went. Would I like to do more? I absolutely would. But the gyro is not mine. It never was mine. It belongs to Rick Zimmerman. And Rick Zimmerman is kind of, his channel has disappeared. Nobody knows what happened to him. He just disappeared. His channel got deleted by YouTube. And with all this COVID stuff, we really have kind of lost track. Now, one of the things that I really do want to try to do is get some of these pieces of equipment again. If we can get this television production company to actually sign off on this budget, and I am more than happy to get ballers in on doing these examinations too, but again, I only have so much pull in the people that I'm dealing with. So I want to find out just as much as everybody else did. But the main thing that I really want people to understand here is, contrary to what the ballers said, they said that I was caught lying when I blatantly admitted that we detected the 15 degrees per hour, when I blatantly told all the steps that we decided to try to eliminate that. Right? They said I was caught lying, and then they said because of the fact I was, on that hidden camera, like I didn't know I was mic'd. When I said, look, if we put this out here right now the way it is, it looks pretty bad, and you guys would agree it would look pretty bad, right? So fortunately, within a few weeks of that, we had come up with our ideas and started testing it, and realized, that that's what was actually happening, and this fell in perfect line with what Sanyak and Mickelson Gale discovered. And of course, so what do we have now? We have 0 pieces that corroborate the ball, meaning it's a ball rotating at 15 degrees per hour, consistently. But we have Aries failure, which is an optical experiment and basically is bulletproof, right? Which tells us that it is the stars that are rotating over the top of us. And we have the change in rotational speed from our own measurements. So we have those 2 pieces of evidence. On the flatter side, we have 0 pieces of evidence. On the Glober side, that's where we're at, guys. All right? It's as simple as that. But I didn't lie about anything, and I want that perfectly clear.
So Bob, the 0 Gauss chamber dramatically affected the ring laser gyro deviation?
No, not the 0 Gauss chamber. I'm sorry, did I say I meant the Helmholtz coil? The Helmholtz coil did.
Okay.
All right, thank you.
All right, thanks, Bob. I appreciate you going over that stuff. You've gone through it before. Can you give me a brief explanation? I may not understand it, and some of the audience may not understand it. Why would the altitude change the reading if we're talking about some kind of Sagnac effect?
All right, now this is something that came up in FE Core. All right, we looked at that. And, it occurred to us, and honestly, this is something that I don't know if anybody ever ultimately contacted KVH about this, but I want you guys to just think about something logical here, right? If we're dealing with a piece of equipment, right, that is designed to operate in a multitude of environments from under the sea to maybe 100,000 feet as far as navigation, obviously it's going to go through pressure changes. Now, granted, the device itself is hermetically sealed, right? But, it is possible that there still could be some effect that pressure could have. Now, do you guys honestly believe that a company that would put out such a precision instrument would build in such a tremendous flaw that no matter where you used it, whether it's at sea level or 50,000 feet or 100,000 feet, that pressure differential is going to throw it off by so many degrees per hour? Do you believe that? I don't believe that, not for a second.
No, that doesn't make any sense. Obviously, they would work that out. It would be useless if they did that, right?
That's exactly right. And that same question came up in FE Core, guys. So don't think we didn't think about that. Again, we're just looking for the truth. All right. If it turns out we're on a spinning ball, you know what? That is a big weight off my shoulders. But I'm sorry, the
Hey,
preponderance of evidence
Bob.
is completely the opposite direction. You know, it's just the way it
Yeah,
is.
we shouldn't even talk about saying if it comes out that we're on a ball, if we're on the flat, because we're not on the flat side because we think it could go back to being a ball. Let's get that clear.
He was
Very
making
clear.
a point about looking for the truth, Rob. I think you may have missed the point.
Yeah.
Yeah.
I get his point too, and I respect it, Bob. But at the same time, I feel like this is going to cause a massive divide. The Globers think they won because you proved right the rotation to them. They believe this shit. They really, really do, and they're going to attack us on this stuff. At the same time, we're almost speculating, and I respect that because we got to find the truth. And I've said this sometimes: if we don't understand what's going on, you have to speculate to get to the truth. But let's make it very clear: we can't validate science-wise right now that this is truthful what you're saying. No, I agree with you. There's something going on, right? But there is no validation. This doesn't actually, for me, prove anything besides we got to look into it more.
Yeah.
Very, very well said. And you're right. And you know what? It doesn't matter what we do. There's going to cause a divide. I mean, for crying out loud, when you look at the ballers and they are so desperate, you know, because there is nobody else or nothing else in history that they can conclusively point to and say this proves Earth rotation. Period. End of story. It's scientifically proven. They can't do that. So when the ballers literally have to say that a flat earther working with the fiber optic gyro, and it wasn't even me at the time that did it, right? Proved Earth rotation conclusively. That's desperation, people. That's all that is.
Desperado. Yep.
Of course.
Desperado.
If they had some kind of definitive evidence, I don't think any of us would be here.
Agreed.
And that's exactly the point, isn't it? So it doesn't really matter what we come up with. The people that believe in this or are hired to promote this, whatever you want to look at it as, are going to keep on doing what they're doing. And some people, you're never going to change their mind. That's why I adopted the strategy a while back. It's like, look, if people are either going to accept this or they're not. And if they do, then come listen to Globebusters, because I'm going to keep saying what I think is going on, you know, especially spoken from a flat earth paradigm, because I'm a flat earther and I certainly see it that way. And I also have looked at the globe earth paradigm many, many times and disagree with it on many, many levels and have talked about that. It's, look, like I said, it's something that it's an ongoing discussion. And I got to tell you, it's a good thing. It's very healthy. Even as much shit as I've taken over this downward acceleration, I have to say I'm glad, because it's really picked up the discussion in the community, and I think that's something that's absolutely needed, and that's what we're here for, isn't it?
Absolutely, yeah, and I would agree with that too.
agree.
There's been a lot of people coalescing around. It's nice to have you in here too, being you know, in the community with us. I guess that's selfish on my part, but to get the discussion going and having your voice around is kind of nice to kick things up.
Yeah, thank you.
Well, I appreciate that. And, you know, like I said, I think that we should all be able to say, you know, what we need to say, and what we feel is right, you know, without being called an agent or a child molester or child rape, you know, anything like that. I mean, that behavior is childish and it needs to stop. And I would tell anybody that witnesses that behavior that they really need to discourage it, because the people pushing it are just puerile.
Yeah, it's not good, no good for any of us. If we want to get the truth out there, it's really not a good look for any of us. To be honest.
It's not at all.
I agree 100% with that, Bob.
I did want to ask you kind of a follow-up to this thing, Bob. If someone were to want to take this to the next level and get their hands on one of these, what would you do with it? What would be your next steps, or what could somebody who wanted to do that go about doing that would be of value?
Well, honestly, the next step I would probably do I would do some control experiments of the fog in a pressure chamber, in a vacuum chamber, just to see, you know, if that holds any water, right? The pressure differential, because like I said, it doesn't seem likely that a company would do something that would be so susceptible to that. But if we're gonna, you know, if we're gonna test all things, then this would be one of those things that I think we should test. Okay.
Well, you also said that Helms thing not the Gaussian one. The Helms thing had a huge effect on the
It
gyro,
did.
right?
It did, man.
Yeah.
It knocked the crap out of that thing. I mean, it was all over the place. Yeah, and honestly, again, if you've been following my discussion on luminiferous ether and the fact that magnetism, so-called gravity, or the downward acceleration, however you want to look at it, and electrostatics are basically, like Ken Wheeler says, three different heads of the same beast, then obviously it's not unreasonable to expect an interaction. That's why I really want to do this next test, as soon as we can find a place to drop from 125 feet, of the two magnets with the opposing poles. Like, if you guys are familiar with the Boyd Bushman claim, where he said he took two neodymium magnets, put either the north or the south ends together, and then dropped them at the same time, and every single time the one with the magnets in it came down later, right? So something was inhibiting its fall, right? It was as if there was some sort of an anti-gravity type effect. We've got the exact same thing ready to go. We just have to find a place. Now, if that happens and we do this and it comes back with a separate drop rate, and I have no reason to expect that it's not going to, then all of a sudden the entire game is changed on everything, isn't it? Right? Then everybody's going to have to do this, because this is an experiment nobody can sit around and bitch about. It's cheap enough and easy enough to do that anybody can do this. So I'm really looking forward to doing this, but damn, it's hard to find a place to do it.
125
exciting,
feet, you
yeah.
said, huh? That's what your holdup is, to try to find a place where you can drop something from 125 feet? I wouldn't think that would
basically,
be that hard.
well, you wouldn't think that it would be, but it really is. And of course, we have to be able to, it can't have a lot of external winds. It would be ideal, but I don't think we could get these people to do it. Is if you guys are familiar with the design of a lot of the new embassy suites, right? They have the big terraces, and they go up, 13, 15 floors. If we could go up to the top floor of one of those bad boys and drop down, that would be perfect. But unfortunately, I don't think the hotel's insurance is going to let us fly with that. So yeah, it really is kind of difficult, guys. So if anybody, especially if they're in the South Carolina area, can come up with a place that we can do that, please let us know, because we really want to do this.
Bob, I
Is
have
there
a
any way to
question, if I
rent?
may.
Go ahead, Essie.
Hey, Bob, when you did the gyroscope test, did you ever put a mechanical gyroscope next to it?
Not specifically next to the fiber optic gyro. We did an entire series of tests with mechanical gyros, and we were never able to get any drift, with the exception of, here's something that happened, and a lot of people don't know the whole story behind this. And we had a guy in FE Core, his name was Stefan, okay? Now, Stefan built this beautiful gyro, but I think that Stefan, and I think this may be one of the reasons that Rick went away too, but Stefan was doing these tests, and he kept getting drift rates, and they were all over the place, and he was doing it forwards and backwards, and he would see different changes in drift rates. But when we started analyzing that, what we found out is that these drift rates would only take place at certain RPMs, and they were like super high RPMs. So what that told us is that it was basically torque created by bearing restrictions, right? In other words, there was a torque being created there because it was only happening at certain RPMs. And unfortunately, what he was doing is he was taking sample rates right at the time that it passed through that RPM. And we got in a huge fight over this in FE Core. I just said, look, we cannot, they go, well, we should release it. And it's like, look, if we release it, then what's going to happen is we're going to get the same shit that happened with the fiber optic gyro. If we cannot come out and positively say, without a doubt that this was a friction type of bearing thing going through this specific RPM range, then nobody's going to want to accept it. And unfortunately, Stefan and Rick didn't want to do that, so they went ahead and they put that data out, and I'm sure you guys saw that, right? But what they didn't tell you is where they were sampling from, and we have all of that data, and they were sampling right at that RPM speed that made it appear that it was doing, because every other speed had absolutely zero drift whatsoever. Any other gyroscope that we ever tested it with had zero drift whatsoever. In other words, there is no damn drift with the mechanical gyro. It doesn't happen, period, unless, and like I said, we figured out what happened with Stefan's, and it was absolutely due to torque created by the friction bearing. That's exactly what was happening, conclusively.
If I could just
Beautiful,
bring
yeah,
it.
because
Where
we
did-
know a
what was the
gyroscope
RPM
keeps
you had it set at?
rigidity in space.
I do not recall off the top of my head. It's been a while, and I don't know if those videos are still out there or not. If they are, they would probably be on Stefan P's channel somewhere. And I think his channel's still up, but I honestly don't know. Let me look. I'll see.
Bob, do you know the drop tower?
Do you
where they
remember
got
the erratic RPM in which it behaved, which it started to process, Bob?
I do not recall that either. But again, it's on the video. Let me see if Stefan's channel is still up. Let me look for it.
Bob, I mean, you know that if you take pendulous veins out of a artificial horizon, you'll watch the thing process.
No, you won't, because, like I said, I myself have a precision gyro. We also bought one of the military ones, and the only reason for the pendulous veins, first of all, if gravity did all this centering, you wouldn't even need these pendulous veins in the first place. So the pendulous veins argument just doesn't hold water. And no, I don't believe that. And I would ask you to provide proof of that.
Yeah, I can do that, but why do you think we have them then, though, Bob?
Because when you're doing radical maneuvers in an aircraft, what it does, it assists in bringing the plane of the gyroscope back to level, and that's exactly what they're designed for. That's why there's 4 gates that air is going through, so that if one is biased off to one side, it will push a little bit harder and it will level out those gates. That is the reason for pendulous veins. And if you don't know that, then you have obviously have not looked into it.
Why there's pendulous veins. I'm just asking, why are there 4?
The Earth is very flat.
Well, basically for 4 different
directions.
directions.
Just explained it to you, dude.
Hold on, Bob. You know the drop.
You
know the place where they dropped the drop tower, where they dropped the elements, and they got the different elements falling at different rates. Is it? What's up?
I don't understand. We haven't done it yet, and I don't know where Boyd Bushman did it. I've just got the video of him talking about it.
Oh, you've never seen the video where they got the elements falling at different rates? What's it used to go?
Oh, that, yes, absolutely. I've seen that one, the really short one where they pop it up. Yes, and see that again. That again also goes along perfectly, right, with the idea that the ether will have different effects, or this downward acceleration will have different effects on different materials. Also, the thing that this tells us is when the Globers are telling us that they're using gravimeters to be able to detect different elements, right, because of different acceleration rates. Well, you know what? That makes perfect sense, because they're going to interact with the ether differently, and they're going to cause a different acceleration. So I'm looking at that and I'm saying, okay, I can accept that. That makes sense to me, and that's where I'm going.
My point was, is it possible to rent time at one of those drop lab places, or will they not let you get in there at all for anything?
I don't know. I don't even know where a drop lab place is. So like I say, I'm asking for help, guys. If you can find a place, help us.
Fair enough.
I did have one real quick question for you.
Can I ask you something, if that's all right, Bob?
And I just have one quick question afterwards. Go ahead.
I've stayed up all night to talk to you, and I don't know when I'm going to get the next opportunity. Do you think it's fair to claim a flat Earth when you haven't definitively proven a flat Earth to begin with? And do you think it's healthier to attack heliocentrism and the claims rather than claim a model, like, say, Mark Sargent with a pizza dish and a dome? Because there's many people in this community that feel that globebusters have done a lot to muddy the waters, because when you're talking to ballers, you're basically arguing a straw man. So you've got a globe, and then you've got a pizza dish model with a dome over the top. So they're 2 straw men, and then you fall into a Hegelian dialectic and a false dichotomy. I've been part of this for nearly 6 years, and you are one of the people who've contributed to muddying the waters. You need to know that.
What's your question, Merle?
So what the hell is your point?
Yeah, which are
Yeah, and
My point is, you are one of the people who have muddied the waters.
Oh, well, thank you for that.
Did you get that?
I'll take that under advisement. Now, let me respond to that. Okay. First of all, do I think it's fair when you say there's no evidence, no conclusive evidence? Au contraire. There's nothing but evidence. We have all the evidence. We have hundreds and thousands of visual observations. We have gyroscope observations. We have first person, we have documentation from the government. We have so many pieces of evidence that it's utterly ridiculous. And yes,
We
a
only
lot of
need
that
water.
you can call as a preponderance of evidence. And you know what? A preponderance of evidence in a court of law will hold up beautifully. But I got news for you. Just the visual observations alone. What the hell
Jeremy,
is
your
that?
mic's open.
Hey,
Sorry.
Jeremy.
Sorry.
Just the visual observation evidence alone, where we can see hundreds of miles beyond where we're supposed to. If you don't think that's conclusive, then you've got a huge case of Dunning-Kruger or something.
No, I don't.
Well,
You're
yeah,
claiming
you
a
do.
dome.
No, but
You're
also
claiming a dome.
Yeah,
You can
and there's
yell as
evidence
much
for
as you
that
want.
dome, and there's
You're
evidence for
claiming a
that dome.
dome and a
There
pizza
is
dish,
evidence for that
and
dome
you
too.
bang out of order.
There is evidence for that dome also.
You're
I don't
claiming
claim
something you
shit.
have no evidence for.
Listen to you. You're
Yeah.
just sitting there saying
Listen
shit.
to you.
Oh. You don't have no
Listen to
evidence.
you.
I've just told you 10 times I do have evidence, and I presented it 100 times on Globebusters. There is a lot of evidence for a dome.
Why
Clown.
is Merle
Can
being
I
allowed
say something?
to
Merle's
At
not
all, please hear
Merle.
Merle.
I have
Merle.
listen to me.
Oh.
I have muted Merle. Merle, you got to speak your mind. You got to say what you wanted to say. I get it. I don't want this to turn into a
Can I-
shit show. So
yeah.
global virus foe was next. He had a question, I believe.
Okay, honey, go ahead. Go ahead.
And not to be a kiss ass or anything, but I completely disagree with him. I think you've done an excellent job for the community. You just put ideas out there. Hey, it's up to us whether we want to accept them or, you're just putting stuff out there for people to look at. So I think that's beautiful. More information, the better.
Thank you.
Informed decisions
Appreciate
are always
that.
better than non-informed decisions. So I think it's a good thing you're doing. Thank you. But I just wanted to ask you real quick. Do you think that, because when we were talking to the ballers about this earlier, apparently their main disagreement with you was the fact that they say that a diode inside of the gyroscope would cause the temperature variation to occur, causing the diode would be affected by the temperature variation, which would cause the rotation variation. Do you think that that's a possibility or no?
Okay, well, again, obviously there are electronic components that have positive and negative temperature coefficients. This is something we've known forever in engineering. But why they would put one of those in there purposely, especially when, again, think about where these things are typically mounted. The navigation arrays, the inertial reference centers, are usually mounted like somewhere around the luggage centers. They're not even in a pressurized container, right? So that means that they are subject from temperatures anywhere from 100 plus to 50 below zero, right? So to think that, again, they would put a component in there that would make it susceptible to make it so incredibly inaccurate because of temperature is patently ludicrous, right? Again, use your common sense.
Yep, that's my thought. And so either they're just wrong or they're incompetent as all holy hell. So yeah, that's exactly what I thought. Thank you.
All right, I'm gonna pay the bills here for a minute. Let me see here. Where the heck did the super chats go? They just disappeared. We've got a couple here. For Chris Berry, please ask Bob how he thinks gyro compasses work. I'm not sure why he's asking that question, but thank you.
Probably because we have one in FE Core, and what we have come up with so far on that is we believe that this has something to do with Lenz's law, because if you guys are unfamiliar with Lenz's law, there's this phenomenon, this very interesting phenomenon too that takes place, that even non-magnetic materials, like you've all seen the copper pipe, right? Copper, which is normally non-magnetic, and you drop a magnet down through it, and that magnet drops through at extremely slow speed. Well, what the hell is happening there? Okay, what's happening there is the magnetic field that is surrounding the magnet is moving. It is in motion going through the copper pipe. When it does that, it induces a small current through that pipe, because it's metal, it's a conductor. All right, and in turn, when an electric field is induced and produces a small current flow, then an electrical field in opposition to the one that induced it then comes out of it. So what's happening is that magnet is being affected by its own inverse magnetic field as it goes down the pipe. Now, we all know that compasses point to the north, right? And the gyro compasses, basically, they have to spin up, and it takes them quite a while. If you guys have ever seen this, like I said, we've actually got one in FE Core, and we've watched it very closely. And so what we think is happening is that there is this Lenz's law that is taking place where it is detecting this northern magnetic source, okay? And it is causing then through the circuitry in there it to come around and detect where north actually is, but not because of any earth spin. In fact, that doesn't even make any sense if you think about it, but rather because of an effect called Lenz's law. And that's my best guess at this point. I could be totally wrong, but that's what I think it is, and that's that's what we've come up with.
Then why do they point to geographic north, not magnetic north, Bob?
I don't know. It could be something that's
kind of rule out your idea that it's caused by.
No, it doesn't rule out anything, because that could, anything could be built into that circuitry, and not only that, it could be slightly off phase as well. You don't know unless you actually take these things apart. Oh, right, and you know engineering, how they work, right? You got it down cold. Let's hear it. Let's hear it.
All right, thanks, Bob. Appreciate you answering that. Chris, I didn't know where you were going with that question, but it was a good question. Elabaka, don't mechanical gyros require high RPM to pick drift? Yeah, I think that that's what you're talking about, right?
High RPM.
And I posted a link showing why they do, and Bob said no. If it would only process if we got it up to a certain RPM. Well, duh, that's why they process so well.
I didn't say that. I didn't say that only process.
That's why a freaking turn coordinator, for example, we got to get going 25,000 RPM in an airplane.
Well, wait a minute. Now I'm thinking back. Bob, didn't you say that they don't show drift?
I said that in Stefan's case, this is where we detected maximum bearing friction, right? And when you have the bearing friction, there is a large resistance there, which is causing a torque, which was causing it to swing around. We proved that conclusively. We know that without a doubt.
Well, yeah, and you can look at any artificial horizon or turn coordinator on an airplane and see this exact idea taking place. For example, the faster you spin it, the more accurate it is. That's why you need not shitty bearings.
Yeah. No kidding. Not shitty bearings are a good thing to have. You're right. But again, I have yet to see you guys, where are your experiments showing this perfect drift rate? Where are they?
I just posted one for you from the FAA. This is why when you're freaking
no. Where's your evidence? Where's your evidence? Where's your evidence? I'm not interested in straw man evidence. I want to know where your evidence is.
Watching Procession? Yeah, I've watched Procession before.
No. Where is your experimental evidence? You don't have any. That's the whole point. You got nothing.
You never watched a mechanical.
All right, moving on.
Pilot for over 40 years. I know what they do.
You were what?
I said I have been a pilot for over 40 years. I know they work.
You're a pilot?
Yes.
Yes. Really? You don't know that about Bob?
Really?
My goodness, guys.
Bob. What are you rated for?
Yeah, we're not playing that game, RC. I appreciate your analysis earlier, but we're not going to play that game. Elabaka CLP 2500. Is there a way to predict ether gyro drift based on elevation and location? Why do underground large gyros working all year don't vary as much? Any thoughts on that?
No idea, and I'm not even sure that's true. I don't know. We didn't do that much experiment to be able to make a claim like that.
Yeah, okay, fair enough. And then there was just a couple of clarifying questions. Do you know what the model of that gyro was that you gave us the data for?
I believe it was the DSP 1760.
DSP 1760?
I think so. Let me double check it though. Okay. But yeah, I think that's what it was. If not, I'll get back to you on it.
Okay, appreciate that. And do you know which of those data sets? I know this isn't your display of the data.
Actually, I don't know. I do know that there's a lot more accompanying information with that. I don't know who has it right now, but I'm making an effort to try and get a hold of it, because again, I have no problem with disclosing this. You know, I am confident enough in the flat Earth model that I don't think anything's really going to hurt it, but I simply don't have that. Okay,
Yep.
so but I will do my best to make it happen.
Oh yeah, that'd be awesome. All right, thank you, Bob. Appreciate that. I am done with my super chats and questions.
Okay, well then I'm going to bail, guys. I just wanted to jump in there, but seriously, watch that Malcolm Bowden video. Then you will understand where I'm coming from and why I'm pursuing the Luminiferous Ether Trail, which I think is hugely important. I really do.
Cool, man. We will.
Thanks for coming, Bob.
Thanks for stopping in,
Okay,
dude.
guys, take care.
Appreciate it.
Bye.
Have a
Cool.
evening,
Good
Bob.
stuff. Good stuff.
I did have one clarifying question. I just did about the data was if they were all done on the same day. That's all. I know they moved around. I just didn't know if they were all done on the same day.
Crap. No, you know what? One of them was and one of them wasn't. The Pikes Peak was not. The Guanella was. And I'm not sure. It was back in like July. God, was it like July of 2019 already? It's been a long time ago. It's been a while.
All right, fair enough. Yeah, if you get any more
Thanks, Bob.
information, we'd love to have it. There's people hungry to analyze it,
I'm
that's for sure.
happy to give it to you whenever I come up with it. It's yours.
Awesome.
I would. What was it? What was the name of that Helms thing where you got a huge deviation from?
A Helmholtz coil.
Helmholtz coil. All right. Somebody remember that.
I got it written down.
I wrote it down. Yeah.
All right. Cheers, guys.
See you later, Bob.
Thanks, Bob.
Another super chat.
Cheers.
Chris Chitteras, fight the good fight. I like that name. Anyone find any bendy water yet? Asking for a friend. Thanks for everything you do. Keep up the great work. Hell yeah. Thanks, Chris.
You know what?
No bendy
Sorry,
water.
man.
I haven't been able to find any bendy water. None of my friends have. I don't know. Has anybody else been able to find any bendy water?
Yeah, all the time.
No, and I've been
Not except
looking.
little
Brandon.
droplets.
Yeah, droplet. I
Osha's
guess
got
so.
some.
Rain. Yeah, that's a little bendy. I guess waves. Those are bendy. But like oceans, like the Pacific Ocean bending? No.
They take the shape of any container forces acting on them.
Right.
So
Yeah. They always
they've been all the time.
They always get in mounds, like large hills that are half the earth wide, and climb a hill of water all the time.
Bob had just said though, it shed some light onto, and I'm gonna have to make some assumptions. But it sounds like that because he's only named 3 locations, and I was like, I wonder where the other locations are. But what it sounded like now is there are only 3 locations, and if you look at the spreads, that correlates with the
That matches. Yeah.
exactly. It matches the spread, and it sounds like the only one that was the outlier that he says like Pikes Peak we did a different day, in which case that makes sense that Pikes Peak was the one that
Spread
was
out.
the super spread out one.
Maybe.
Yep. I agree.
Maybe. Yeah.
Excuse me, Brendan. Would you mind unmuting Merle if he? Oh, you have. Okay.
I already did.
So I just caught.
I'm
Bob-
very interested in this Helmholtz. I'm super interested in this Helmholtz coil thing. Does anyone even know what that is, or?
Well, I was looking it up. I don't know. Is anybody on the panel familiar with a Helmholtz resistance or what a Helmholtz
Not a clue.
cavity is?
Coil.
I mean,
Well, he said coil, right?
Yeah, he did say coil. I couldn't find coil. I could find resonator.
I know they use it in like what do you call that? Like magnetic what do you call that? Magnetic containment. Like whenever you make like one of those fuser, which is like it's almost like a tiny little it's like a little vacuum chamber. You put hydrogen in it and you contain that hydrogen into a pressure using magnetic containment. I think you use things like that to do that.
Okay. Yeah, it's talking about all kinds of stuff. I'll put the link in the chat if anybody wants to go check it out. Maybe somebody can find. I remember seeing it in a video, like when he presented all this way back in the day, that they were talking about. We did some different stuff. We used the Helmholtz thing. We used this to try to rule out these variables, but I haven't been able to find that video, and I guess it's kind of gone unless it's on a secondary page out there somewhere.
Yeah, and all the Globebusters videos are gone now too. I tried looking for a Globebusters video that showed the ISS fakery and how they cut scenes a lot in it, and now it's all gone now.
Bob
Well, they're
just
not
posted
going to make it.
9 times in the chat. There you go.
What, the Helmshold thing?
Yeah, I think it's the same one that I had open. Oh no, it's a different one.
All right.
Cool. There is a Helmhold coil. You guys are right. I was wrong.
All right.
There it is.
Save that, Brandon, so we can look at it later.
It is a coil. Thanks, Bob. Thanks, Bob.
I feel like every
Thanks, Bob.
time we're saying that, yeah. All right.
Can I
Bob.
say something real quick against, not against, but what it's basically after what Merle had said. And this is, I understand how people can feel that there, like I said, there's a divide with people's opinions. But just like Ranty, who came on my show, got, respect to him, who felt differently about this ghost virus thing. He had his space to speak about how he felt about it. We all have our different opinions. And Bob's even said today, this is a more of a speculating and trying to get to some truth here. Now, I know a lot of people in this community do not like speculating, but how the hell are you supposed to get the truth if you don't have it and you can't scientifically prove something? And we want to get somewhere besides the echo chamber that we are always in, right? This isn't for Globers. This is for us to find truth. And that's what Bob's trying to get to. Now, it doesn't agree, right? It doesn't actually prove anything here at the end of the day. And I don't like, Merle, that you said that there's no proof of flat Earth. It's not our burden. The burden is there's no actually proof for the globe. That's their burden. There's absolutely none. There's no data that shows that there's rotation. There's no data that actually shows there's curvature. There's nothing of this. So why are we worried about what someone else thinks? Because we have to talk about this shit.
I believe
the scientific method is not the only way. My bad. Go ahead.
I'm sorry. I just say about the burden thing. I believe in any argument where two positions are held, that the burden is 50-50 when each side bears a burden.
No,
well, that's
they're both straw men. The globe and the dome are both straw men. It's a false dichotomy. There is no flat Earth.
Yeah, but hang on, Merle.
Merle, you're on one today, bro. What's going on, Merle?
There is no flat Earth.
Yeah.
There is no sphere or globe.
There's no spoon.
So where does that
like
leave you? Get real
about
about
like
it.
Samantha. What do you mean? Why don't you elaborate for us when you say there's?
Well, maybe I'll try if I don't get muted.
You got muted because you were about to turn it into a shit show, Merle. Something I specifically asked you.
He called me
not to do.
Dunning-Kruger.
Well, it was going downhill, and we're here. We were trying to get information
he
from
can't handle
Bob,
himself
which
without
is what I
being
told you at
protected.
the beginning. I said I want to get I want to hear what Bob has to say about this. I don't want to turn this into a shit show. You know, I don't mind a shit show. I just didn't want that specific portion to be turned into a shit show. And I had told him previously, if it started turning into a shit show, I was going to mute people.
Well, I'm not here to troll. And when I was first out here, and none of you guys were, we had a situation on our hands. Okay? That situation was that we didn't know what the Earth was. Amazingly, that situation hasn't changed.
I've been here.
We don't know if there's a dome. We don't know if there's an ice wall. We don't know how big it is, if it's part of a bigger system. I mean, there's real voices in this. We don't need shills and gatekeeping and censorship. That's not helping
Dude, are you
anything
okay?
Merle,
progress.
well, I agree with you.
I'm
We
frustrated
don't.
with this situation.
I bet you 100% of the people on this panel agree
And
with that statement
I've been
that you
here,
just made, Merle.
I've been here longer than any of you.
Who cares?
Nope,
You got your
not
fucking
you, Merle.
old age card. You're fucking the OG
you're
fucking
jaded.
flat
Yeah.
earther, bro.
Yeah.
Who cares?
I am battle
Come on,
weary.
Merle.
I am battle weary.
Merle, what's
I'm
wrong today,
tired.
bud? I know. Why don't you go to
Then take a
sleep,
rest.
take a nap?
I've
Yeah.
been up.
Take a
I've
rest.
been up all night to talk to some fat shill, and look how far I
Jesus
got.
Christ,
You
Merle.
stay up
I'm gonna
24/7
fucking mute you
to
again.
kill,
Merle,
Merle.
go get some sleep. For your own good, I'm gonna fucking mute you.
24/7
Go get some
kill,
fucking
Merle.
sleep, bro.
You gotta go.
This isn't
You're
that
up,
important.
Manly.
Bob is not going to solve this problem for us. We're going to solve this problem
Right.
eventually, hopefully, okay? Or you've already solved it. This is down to you
internally.
to decide if you have
Brandon,
enough.
it's
Shut the fuck up.
Whoa, Brandon, I'm on your
I mean,
side,
if
bro.
we're talking about
Well,
our
please
feelings,
don't talk over me when
gotta
I'm in the middle of having a fucking conversation
Sorry.
and trying to say something. I'll give you the floor right afterwards. All I'm saying
if we're gonna
is,
talk about our
I can't even
if we're
remember
gonna
what
talk
I'm
about our-
saying. You go ahead. Shit.
Jesus Christ.
If we're going to talk about our feelings, I feel like Bob is the most respectable of the flat earthers because he's doing the most experiments.
I would agree with that. I got to be honest. I agree with that
yeah.
totally.
He's out there. Yep.
That's what I was thinking when he was talking. I'm like, at least he's fucking
I
doing
disagree
something.
with him on most of his assertions, but I do not disrespect the fact that he is actually out there spending money, spending sweat, doing his shit.
Fucking A. I agree.
It did take a lot of guts to drop that data off yesterday, you know. Yeah.
And to come back in.
Yep. Yeah.
I mean,
we'll put it this way: he's given more data just with that freaking thing than I have ever seen from a flat earther when it comes to actual raw data.
Well, don't get carried away, okay? There's other experiments that go on in the flat Earth.
No, but I'm talking raw freaking data that we can actually deal with.
Yeah, it is a lot of data, and that was a lot of hard work for them to go out there and go to 3 different locations and all that shit and do that to get the compass in the first place. So I agree, it's good, it's awesome.
That's not that hard. That part's not that hard, but neither is dropping off. I think as far as, you know, without him. Because I'm sure if you have something like that, like if I was a flat earther and I had something like that, I would probably want to have an explanation for why there's 15 degrees before I release that.
Oh, fuck
and
yeah.
I'm pretty sure that's probably why he's reluctant. He was reluctant because they didn't completely suss out, you know, what their reason is, which is fine. So I mean, I do think that there's some honesty and a little bit of bravery even in releasing it.
Hey, Kosho,
Can I
imagine
ask
if
you
you
a
were.
question, Kosho?
1 second, Stacy. Imagine if you went out and you did whatever your GPS experiment that you're talking about, right? And the data came back and you were like, holy fuck, dude, this shows that there's no drop whatsoever.
Yep.
Would you be out there screaming it day one, or would you be digging into every fucking corner of that data, trying to look at it 1,000 different ways to make sure that you're wrong?
Yeah, that's what you should do.
You should assume,
even
yourself.
because of a bias, you should assume that maybe you've done something wrong and try to look through it and see maybe if there was something that you did that was wrong that could have made it happen. So yeah.
Yep. Go ahead, Stacy.
Needs to be repeated multiple times for that test to be accurate and know that it's been done over and over. Different days. Do it again, even now. And I know that can be done eventually. But the point is, I'm asking Kosho, with this data that you have received, and I'm asking you from a Glover's point of view, does it prove anything to you? Either side, has it proved anything to you?
I mean, it absolutely confirms what he was trying to disprove and what I knew from other reasons. It just it corresponds with that perfectly. So.
Since coming to speak with flat earthers, I understand infinitely more about how and why we know that the Earth is a globe. That is for sure.
Yeah, everyone
so from your
learned a
point of
lot.
view, if I get it straight, you've learned and you think that Bob has proven what? Rotation to you?
Rotation. Yeah, I mean, he showed rotation with his data.
And here's the thing about the results. The gyro is designed and built to detect motion. You put it on a surface, the surface moves, it detects the motion in free space.
And it's just point. That's it. Simple as that. Simple as that. Left lane.
But no, let me make my point.
All right.
Maybe it's ether, maybe it's temperature, maybe it's altitude. You know, it's kind of a bunch of assumptions, as opposed to it was made to detect motion, and that's what it did.
So the gyro's not just. Hold on a second. Hold on a second, Micey. Hold on. We just heard from 3 Globers in a row. Let's have a flat earther jump in every once in a while. Now, if the gyro was, thank you. Gyro is just picking up rotation. Why are we having deviations? Clearly, there's something else affecting it, right? It's not that simple.
We have to ask more questions. A question I would ask if he was still here was how was this housed? Because that would, like he said, he would want to do it in a vacuum chamber, and I would agree that doing it in the most that would eliminate the temperature and pressure sort of issue, which I think just purely the temperature is going to change a lot. And so that's why I'm looking into what this model is and how the temperature affects it, because I know that Like you can personally house it in different things depending on what you're using it for practically. But if it's not housed, it's possible that you know that it would produce errors just from not being shielded from anything. So depending on depending on how shielded it was from the temperature and how shielded it's supposed to be, could completely answer why there's so much deviation.
I had a question after you're done, Jeremy.
Yeah,
I'm all done. I'm just saying it was more than just rotation, obviously, because it's all over the place. So it's not as simple as Left Lane put it. It doesn't prove that the Earth is rotating at all in any way. That's all.
Well, the point
Oh, go ahead.
Sorry. The point that I was making, and it was a very simple one to Bob yesterday, was if we look at what the thing does, aka whenever it is angularly displaced, it shows a reading. He has never calibrated it against anything other than angular movement shows the displacement. So if he then sits it on the ground and it shows angular displacement, then guess what? The ground is angularly displacing. We can't, again, look at a voltmeter. I calibrate it to 0 is 0, 12 is 12 with a known voltage, and then put it on a piece of wood and say, this is measuring the temperature. Like, that's not what the thing does.
Well, if you don't change the volts, but you do change something else, and then your voltmeter reading changes, you got to assume that there's something else happening there, and it's not just reading the volts, right?
No, I've already calibrated it for it's definitely reading the volts.
Okay, and then other variables make it read different amounts of voltage.
Sure.
You can't say that it's just measuring the volts anymore because there's other variables affecting it.
And we have
which is what we have here.
And hold up, and we have all of those variables such as temperature, pressure, all those types of things. What we don't have is an ether variable. So him invoking something that he is not measuring for and doesn't know how to measure is nonsensical.
Right.
Yeah. And I would just go back and say that's just what they told you they calibrated it again. So you're believing that, okay, this is what it's going to measure when you don't actually know that. So that's your assumption. That's fine. You can believe authorities all you want. That's no problem. That's your issue. No problem.
Hold on.
But
we don't have
a question.
Hold on. We don't have an ether variable. We also don't have an earth rotation variable, if you want to get down to it.
Well, we do have an angular displacement. Hold up. We do have an angular displacement variable.
That's
and
the phenomena. That's the phenomena that we're seeing, right? That's the observation. That's not we don't have a variable that we're manipulating called earth rotation.
No, this is not an experiment with, a QE style, we're talking about variables in terms of data collection. The data collected from this instrument had, I don't know, I'm looking around like 32 columns worth of data here. So the point, we're not talking about an independent dependent variable. We're simply saying, what does the thing measure? The thing measures angular displacement.
Because you assume
and
what they tell you
something else. It measures.
It
might
measure.
measure
It could be something else. You don't know.
Yeah.
You just.
It's either not.
No, we don't know. That's the whole.
Can I just interrupt?
I think it might be Little Green Pixies.
Hello?
Yeah,
Hello?
exactly.
Can you hear?
You can't invoke something
Gleam.
that
I
you
can
don't
hear you,
know
sweetheart.
as an explanation for the thing that you've already calibrated for. That's nonsensical.
Can I just interrupt and just say,
no problem.
RC Meister, you're wrong there because the Sagnac effect, Sagnac himself didn't believe in Einstein's special relativity. He believed in the ether theory. It does, because that is the original guy who interpreted the results of his own.
That is
his own
incorrect.
effect.
We're talking about an interferometer here, and because of that, we know what interferometers are actually calibrated against. It is angular displacement. Done.
And that's exactly what he done. He spun his equipment, angularly displaced his equipment, and his interpretation. The experiment produces the same results. It's just the interpretation on what the actual results mean or are caused by.
No, you actually calibrate the thing to say what causes it, what a calibration on an instrument is.
So you can calibrate the Earth spin.
You can calibrate the thing to make sure that you're measuring angular displacement and ensure that angular displacement is the only thing that this thing measures. and then you set it on the ground and you watch it read angular displacement, well, what's it mean? What's that mean?
But I could interpret it as that is the sun. The sun also moves around at 15 degrees per hour.
It doesn't measure sunlight. We didn't calibrate it to measure sunlight. We calibrated it to measure.
The sun doesn't just give light. Come on, it's got a sphere of influence in all spectra.
What's moving?
I got something for you guys on this. I was over at Gem.
That's the point.
Hold on, Crit. Let's let Gleam and RC go back and forth on this, and then I'll let you pick up there, Crit.
Sounds good.
Cool. I did still want to ask my question if I can get a chance to ask my question.
Global virus, and then Crit. Go ahead, guys.
Thank you.
All I can say is it's a conceptual change. Even Einstein admits this, although he's obviously a firm believer in the heliocentric model. He said, due to relativity, the argument between Ptolemy and Copernicus back in the days was meaningless, because you can have either coordinate system. You can have it as a static stationary Earth and everything spinning around it, and you can interpret those results on that Sagnac effect as you're measuring the spin around of the whole universe around Earth. And the same goes with flat and globe. You can interpret whatever result you wish in whatever way. You just have to have a cause, obviously, and evidence for that.
You don't add the cause. You actually calibrate the instrument to measure what it measures. And we calibrated the instrument
based on interpretation.
Excuse me, hold up. It's not an interpretation when I hold the instrument in my hand like a voltmeter. Okay. Measure the volts on one thing, measure it to be 0, calibrate it to 0, measure it on something that is known to be 12, calibrate it to 12, then put it on something and see 4, and then automatically say pink unicorns cause these are 4 pink unicorns.
No, because this is the basis of the theory of electrons based on Hendrik Lorentz's work. Because if I now say to you, okay, you've got your measuring equipment set to 0, however, that's set to 0 in an environment full of energy. So you're actually set to 0, but there's an underlying 0 point energy which you have not considered, and you have completely negated by setting the scale to 0.
You don't ignore it, or you don't negate it if you don't calibrate for it. That's the point.
You don't negate
it. It is a non-factor if that's not what
influences don't exist if they're not in the calibration process.
It's not that influences don't exist, is that you can't invoke influences on something like that as as the primary motivator, primary cause of this instrument reading, when you have no way of measuring that other variable that might exist. You have no way of measuring ether. You do have a way of measuring temperature. You do have a way of measuring pressure.
No. I think you're missing it.
Measuring altitude, and all of those variables are included with this one. We don't have a way of measuring ether, therefore we don't just invoke ether.
Okay.
Especially when we don't know, or you can't explain how it affects my interferometer.
We don't have a way of measuring space
curve, and you also don't.
No. Hang on. He's totally missed the point.
What? Well,
you know, ether is the same mathematics, identical mathematics. Neo-Lorentzian ether is identical mathematics to special relativity and general relativity. Are you aware of that? Sorry.
Probably not.
No.
Okay.
Hey, Gleam. Sorry to interrupt. Can you also tell them that they use Euclidean geometry for it too?
There was.
My point is that
space-time does not.
So, Gleam, I am 100% open to the idea of an ether existing. Okay, I have no qualms against that. I'm not married to Einstein. Right? It doesn't matter to me. Okay.
Einstein admitted
the point is that if it exists, then tell me how you measure it. If you tell me how you measure it, show me you doing that, and then show me, just like with a voltmeter, how you calibrate the way you're measuring it.
Okay,
with an accelerometer, or with an interferometer,
I will answer.
I can turn it 90 degrees, measure 90 degrees, and then ensure that it's reading 90 degrees. I can turn it 45, 45, 45, and just keep doing that, right? Tell me how you do that with the ether, and then we can be speaking on the same ground.
We'll let him.
I'll tell you immediately. Although I can't show it you because I've never done it myself, it's a well-known effect in mainstream science called the Casimir effect.
Okay, could you post a video of someone calibrating an instrument that measures this effect?
It's a quantum effect. So you get two non-conductive plates in a vacuum, and they will draw towards each other because of this 0 point energy.
Okay, like I said, can you show me? Can you show me an instrument that is used to calibrate it? Like my ask still stands.
Quantum
show me an instrument that's calibrated towards it, how you calibrated it, and then how it measures ether.
Give me 2 seconds, sir, and it'll be in the general chat.
No
I've
problem.
just got to search for it.
So while you guys are doing that, my quick question for everybody was just simply for any glober out there, if it comes back that we discussed with the company that made the ring laser gyro or whatever gyro it is, the fiber optic, or no, the ring laser gyro, no, fiber optic gyro, that's what it was. If we talk to the company that made that specific one and they say, okay, it's hermetically sealed and there's absolutely no way temperature or pressure could have any effect on it whatsoever, and you ballers verify that and believe that, would you then come back and say, okay, if we have altitude and altitude correlates to these specific readings of, 13, 15, and 17 degree hour rotation depending on the altitude, and temperature and pressure don't affect it at all, would you then admit, okay, there does seem to be a correlation there that could show that it's the ether, or are you still too dense?
No, here's the point. If you actually show that thing and then you're able to show us how it works, and especially from the company or something like that, let's look at it then. I'm not going to preemptively draw a conclusion unless I can see what the actual data is.
If you can eliminate those two variables, temperature and pressure, which ballers seem to keep coming back to as that's the reason we're getting these slightly off readings, and it's
Nobody
not just
said it was
15.
a reason. Everyone says it's a correlative variable.
Okay, just any baller except RC. I like you, RC, and I get where you're coming from. You're really cool. Like, you seem like a nice, down to earth guy. But what I'm saying is that I think that you're stuck on a presupposition that since it's already grounded in this way of being, it must always be this way. When, as Gleam was trying to tell you, there's other ways of viewing it that you just think it must be only one way, and that's fine. I get where you're coming from. But just any other baller, if let's say out of thin air, they come out and say, okay, we inspected this and there's no way temperature and pressure can affect it, would you then at least think that it's possible that it could be very much that it's the obvious correlation being the ether?
That would only be possible if that wasn't already available, and because it is already available, I would only be speaking on hypotheticals that are not going to possibly happen.
Right. It's hypothetical.
We know the temperature changed, and also I'm reading that they don't come housed like that. It's like you can get different housings for different things, and we don't know what kind of housing they had for it, but we do know
right. But
the temperatures did.
Let's say we took care of all that. Let's say it just.
Yeah.
Go ahead.
I was saying we do know that the temperatures indeed did vary with them. So if we did not know that, then I could say, yeah, I would have to agree with whatever the manufacturer said. But since we already seen that the temperatures did vary, then it picked it up.
No, but it might not be the temperature that's causing the variation. The temperatures could vary, but it might not affect it at all. It could be the altitude, and that just correlates to the temperature. You see what I'm saying?
If you look into the silver tooth effect,
it doesn't affect it at all. Does that make sense?
It does, but as I said earlier,
for me, Kosho will probably agree if you guys come up with that. But for me, all this hasn't really proved anything, and that's the point. We're talking about. We always talk about validation all the time with Flat Earth. Has to be validated. And right now, this is not a scientific experiment. This hasn't been repeated over and over. We're looking at data. We talk about all the time. We don't want data from you guys. We don't want data. And even if you gave them the correct information, you're going to get somebody like in here said earlier, maybe it was the wind or a fly. I mean, no matter what we come to, they're going to deny anything that we give them. But it's about the point. They don't have the information. They don't have the proof for any curvature. They don't have the proof for all the stuff that we talk about. So instead of focusing on data, right, that we cannot verify and validate that's actually happening, we're assuming things, then we need to get back to what we can validate.
From what it sounds like, this Helmholtz cage thingy, that would have been the thing to see right there. Because I mean, that nothing should throw this off. If this is rotation due to Earth spinning.
They're going to wrap up with the answer to it. The Helmholtz thing is only going to affect electromagnetic radiation or electromagnetic shit. But I just wanted to finish the response because to wrap it up, the only reason why I said earlier that it seems like it's the temperature and not some correlative thing with the temperature is because the fact that when the temperature is the craziest, that's also when the data was moving around the craziest, and the altitude wasn't being changed during that time. So
gotcha. That's what we think. Yeah,
We've got
I
large
agree. I agree.
variations
That is
in
what it
that
was.
data set, though, Kosho. I mean, you're really hanging your hat on that one data set there.
Well, hold up. Number one, we have to realize like this is a 10% variation, right? Maximum 10% variation in what we actually see. And I've actually, since this has started, I've been listening while I'm working here for a couple of things. One of those is the measurement of air temperature. Like you can actually use interferometry to measure air temperature and pressure because of how predictable these changes among air temperature and pressure are when it comes to using interferometers specifically, right? So what's to me actually kind of amazing is that, you know, I had heard about this kind of stuff in college, but it's not something I'd thought about in years, but it is actually a thing, right? Where temperature and pressure do affect how using interferometers works. And in fact, we understand it so well that we can measure pressure and temperature based on how interferometers are affected in the same air, but using different pressures and temperatures. I just posted a good article on.
And really quickly to wrap up what I was trying to finish up there, because this is the last thing I want to say, and then I'll go on mute for a little while too. But I just wanted to say that I just wanted to see how honest ballers are, and if they can look at this data and say that okay, that can represent both flat Earth and our version of Earth, because it definitely could show either. It's not conclusive 100%. So I just want to see how honest ballers really are, because that definitely matters. So I just want to check where you guys were at, because I mean, I'm honest enough to admit that it could represent either way. It's not 100% conclusive, like Stacy was saying. This doesn't 100% prove anything. It should at least make you think, you know, okay, well, our side could be wrong based on this, and the other side could be right, and vice versa. So I just want to see how honest you guys were. Thank you.
Thanks, Global. Crit.
Only a few of these Globers are really honest, to be honest, and you're going to get that from a few that will admit it or say maybe. But most of these Globers will never, ever concede no matter what you give them.
It's so hard for them, isn't it? It's amazing.
Hey, listen, I will concede if there is evidence.
I just posted some links in there, RC. Anyway, you don't have to believe the Casimir effect, but
No,
trust me,
I don't
it's
have to believe anything. You're right. If there is
it's a
evidence for the
mainstream.
if there is evidence for the Casimir effect and how it is correlated with ether, then cool beans.
Yep. If you look to the likes of Paul Dirac was a keen promoter of the ether, and he was the father of quantum electrodynamics. He was in nature basically saying we're rather forced to have an ether because you cannot reach zero in a vacuum. And that is just the conceptual change. You've got Einstein world, which is no, you don't need light. Light doesn't need anything to propagate through, and the empty vacuum is the empty vacuum, or it's basically matter overlapping other matter, and there's no one set bit of space that doesn't contain matter. Whereas from the opposing point of view, which is the Neo-Lorentzian style, is it's full of energy, and that is what has now developed into quantum field theory, which is background dependent. Everything lends its energy from the background, these virtual particles popping in and out. And
So my question though with it isn't like, is Casimir effect real? Like that's the first question. The ultimate question is, can this be used to explain or show correlation with a 15 degree per hour drift adjusted for temperature and pressure?
Well, with the Casimir effect, obviously something's got to be there. These particles aren't popping out of nowhere. That's a first law violation. So
they would be on the tiniest quantum scale. However, put it this way: if you disregarded the ether, as Einstein did, as science did, and then do not account for it, and then something else is influencing this, and you're getting this definite, no, there is some additional that we cannot account for with just the properties of the matter that we've manipulated. There must be something else in the medium or in the vacuum of space. So That has been proven. That is why quantum mechanics or quantum field theory is now the particle model.
Yeah, but you said it yourself. Because I was going to say it to you in the chat, but you just said it yourself that the idea of what the ether is and all the requirements that it, the reason why we required it got subsued by and then completely explained by the quantum field theory, which is the most successful theory of our universe. And so it's accurately described. I mean, it's accounted for, and not everything's known about it. But the idea of what the ether was before, all is now explained and corrected and understood by the quantum field that carries the photons and the electromagnetism. So yeah, so I understand that it does the Casimir effect, that the what do you call that? The virtual particles that are created can create the Casimir effect. But when you think about the magnitude of what's happening with the this gyroscope, I don't think that it's a possible candidate for the deviation in this gyroscope.
Are you saying they covered that in the Einstein reboot there, Kosho? Is that when they updated that during the Einstein reboot?
And my question is even more fundamental. It is simply, can you show how it, I won't go as far as Kosho said as oh, it can't. I'm just saying, show me how it accounts for 15 degrees per hour on an interferometer. That's all I want.
Yeah, I can't relate that to you. I'm just saying the conceptual, put it this way, what you'll say it is the rotation of Earth, which is in essence gravity. Comes down to the core of gravity. You're going to say it's gravity, and the Earth spinning, that is the influence of space-time. That is what's causing this. Yeah. On Bob's side of the fence, he says, no, that's ether. Both are identical. And just to come off of what Kosho just said, Paul Dirac come up with the mathematics for what is now known as quantum field theory, basing it on the concept of an ether. So his Dirac sea was his concept, and that's been re-established, let's say, in the Fermion causal systems. But the mathematics that Paul Dirac first come up with for his ether model, let's say, that he never finished, that maths was then taken by Feynman et al., and he done his nice diagrams to explain this complicated maths, which worked so well. So, and what they did, all they did is change the concept to, now we can't call it ether. That's got old taboo, older connotation with failure. So we're just going to create it as these particleized virtual stuff. And just by saying virtual in a physical, in physics, virtual is kind of contradictory. So they've had to come up with this virtual particles, this anti this and anti that, to account for this additional thing that they can't explain with just classical mechanics.
Well, no, that's what I'm saying to you, is that instead of saying that they're trying to hide the ether and replace it with this, they're explaining the reasons why they thought there was an ether was to be the thing that light traveled through. And then they realized that there's not an actual medium, because the quantum fields aren't actual mediums, but they are fields, and the light is traveling through that field. Those names, the stuff that they discovered, wasn't on top of ether. They just realized that this thing that they're discovering is exactly what, it fits the requirement that they thought they needed the ether for. So I think that's why it's got a different name. I don't think it's because it was taboo or something. But yeah, you're exactly right what you said about Paul Dirac and Feynman.
Yeah, I can cite someone right here, right now. Robert B. Laughlin, 2005, he wrote a book, A Different Universe, Reinventing Physics from the Bottom Up. He literally says relativity actually says nothing about the existence or non-existence of matter pervading the universe. Let me just read it word for word. Only that such matter must have a relativistic symmetry. It turns out that such matter exists. About the time relativity was being accepted, studies of radioactivity began showing the empty vacuum of space had spectroscopic structure, similar to that of ordinary quantum solids or fluids. Subsequent studies with large particle accelerators has now led us to understand that space is more like a piece of window glass than ideal Newtonian emptiness. It is filled with stuff that is normally transparent but can be made visible by hitting it sufficiently hard to knock out a part of it. The modern concept of the vacuum, confirmed every day by experiment, is relativistic ether, but we do not call it this because it is taboo. And that's in his book.
Well, yeah, that's his idea is the reason is because it's taboo. But I agree. What he said about relativistic ether, you could describe it like that offhanded to somebody, and they're like, "Oh, that's kind of neat way to say it." It's just not what we call it because
it's just changed
But I
name.
agree. It would be about the same thing as relativistic ether if ether were ever identified as discreetly instead of, because there's a lot of different definitions for ether. But I agree that one of the definitions was that it was static, and so making it relativistic, I mean it fits more to description. But like I said, that's his personal his personal title for it. But it's not called that for taboo reasons. I don't think it's just because
he's a Nobel Prize winning scientist, so I'm citing him word for word there, and I trust him, and I've got dozens of quotes here from the likes of Leon Lederman, which are more up to date, more put it this way, and not a lot of people know this, but absolute and relativistic absolute, let's say, which is the Neo-Lorentzian ether, which is basically relativity with an ether, where you can't detect that there is an absolute frame where everything is measured against. Yeah, it can be out there. It can be one of these relative frames. However, it cannot be detected. And there are many people now who think, or many physicists who would argue, I mean, it's science at the end of the day. You'll have a lot of people, obviously, on the relativistic side without ether, but there is definitely a massive load of respectable physicists who do fight that corner, know an absolute frame is much easier to work with.
Well, yeah, I agree with everything that dude said. The thing you read, I agree with everything he said. But I'm sure you know that at the end of what he said, that was his personal artistic title for it, and he's just portraying that to the reader. But I agree with everything he said.
Yeah, I mean, Leon Lederman, you must have heard of the God Particle. That was a book.
Well, the book, The God Particle?
Yeah, it's called God Particle. If the universe is the answer, what is the question? It was written in 2006, available everywhere. And in the back of it, he explains what the ether is. And it's just got a little short word saying the ether, invented by Isaac Newton, reinvented by James Clerk Maxwell. This is the stuff that fills empty space of the universe. Discredited and discarded by Einstein, the ether is now making a Nixonian comeback. It's really the vacuum, but burdened by theoretical ghostly particles. And again, another Nobel Prize winner.
Well, every particle has a unique and its own quantum field. So there's I forget exactly how many quantum fields there are, but there's something like 20 something quantum fields that we know of, maybe more. But I mean, I don't think that any of them are. They all have their respected. They have a particle that's attributed to each one of them, or boson or whatever. So I don't know if there's like just one that has no relationship to anything else, like an ether that's not detectable. It would be irrelevant then.
Well, it's said to be the Higgs. That's what it is. That's all you can relate it to. It's the birth-giving particle or field, the Higgs field. We've detected the particle, but there is obviously theoretical. That is the evidence for the Higgs field, which is the underlying.
Field,
yeah.
And each boson and particle, they have a respective field.
Yeah, and that is it's merely a conceptual change. I mean, I hate watching it. I've been in it as long as Mel, and I've hated Bob being slated, saying, "Oh yeah, thanks for proving this, that, and the other," and it's not. At the end of the day, he takes a different point of view to where you say gravity is. The same mathematics works if he says, "I believe that's ether." Now, it may not work in as much as flat Earth versus globe Earth, but the conceptual change is cemented in science. No one can take that away, and everyone laughs at him thinking, oh, he's unscientific saying the ether and this, that, and the other. No, the gravity is embedded in ether. They're like brother and sister. Put it that way. They're exactly the same thing, but just with a different name.
See, that's
But
very different.
in saying that you can't prove gravity, so therefore we haven't been able to prove ether, correct?
That is a very true statement. I will say that.
There's three things that they can't be related to both those two things. So earlier you coupled gravity and the rotation of the Earth, which I don't think should be coupled for any way. And then just now, when you said that it was the reason for the gyroscope, that could be possibly this ether, this background, quantum fields or something. But you're also saying that it's also ether also has the same. It'll give you the same values or the same findings as gravity. But again, I don't think that those things are the same. I don't think gravity has anything to do with the reading on the gyroscope or the rotation of the Earth or anything like that. I don't see how the ether could be related to the downward force.
I think there's a little bit of double speaking going on here. Isn't the ether supposed to be the absence of all stuff, all matter?
Well, that's the thing. When you suck out everything in a vacuum, what you're left with is supposed to be either in the Einsteinian world, nothing, or the odd one particle. But in the Einsteinian world, there is nothing contained within that medium of space. But in the etherites world, there is something there. It's a bags of energy, and that's quantum field. That's quantum
field theory. Is the quantum field.
I don't agree with that completely, because when you take out
Does
all the
anybody
gas in a
prove? Oh, sorry,
vacuum,
Sierra.
when you take all the gas out of a vacuum, you're left with the magnetic field of the Earth, aren't you?
Yeah, no,
That's still there.
100%. Yeah, no, you're exactly right. Unless you get rid of that influence, and then we're going into fairyland and space, which
You also left with gravity. Then, if you're left with magnetic field, you also left with gravity.
Hey, before we go on to other things and distractions, I want to give Crit a chance to ask a question because I told him we'd get back to him a while ago. Crit, did you have something?
Yeah, I got two things here. So when Bob dropped the info yesterday, and also told everybody how to interpret the data, you had people jumping on it, jumping in it hardcore. And one of those people was this character called Fudge. Fudge, or however you pronounce it. He's basically a sycophant. Yeah, he's basically a sycophant over at Science versus Pseudoscience. So of course he jumped on trying to debunk Bob to fit the Arwen narrative. And what he produced though was actually he showed that most of the data not only goes outside of the device, that it also doesn't even really match very well if you try to fudge it. So like I sent a screen cap there where I drew two purple lines. It shows how much of the data is outside of the limitations. Because if their story is true, everything should be within plus or minus the 2%. I also sent you the schematics for that gyroscope or fiber optic 1760.
Okay, I think I'm sharing. I should be sharing in the Discord what you sent me right now, and then the second one is the schematics. Is that right?
Yeah. Then a couple down shows you the schematics there.
Okay.
They say if you get this offset at 25 degrees Celsius, it could do plus or minus 2 degrees per hour. And even if you fudge the number, if you fudge the numbers, you're still going to get lots of data points that are outside. So then the next thing I did was I looked at the data that Gary or osmosis, whatever, and I weighted the values based off how long each measurement was taken, and then tried to just work out a straight average of all 10 data sets. And it turned out to be about 14.05. So that's weighted. So that's almost a full degree off per hour. And I weighted it because some readings were longer than others. So it's like that would be like if you got a read, say if you took a 10-minute reading and got 5, and then took like a 1 second reading and got 500, that doesn't seem like you just average the two and say that was your result. Like the longer reading has more
The
weight.
Earth is very
It's an
flat.
8% variation. You're telling me that there isn't an 8% error in this thing?
So the
Plus
next thing
minus
you look
2.
at, the next thing you look at too is like if you take a measurement of something, right? You want to actually measure something like X. And do you have to work out stats to figure out what the measurement is, or do you just read the number that's what it's telling you? Like here, I want to hang a picture frame here, and I just want to hang it 2 feet away from the wall, or from the swing of the door. Do I measure 2 feet like 100 times, and then determine what is where 2 feet is?
Yeah.
So I think
just
one
do
thing
the
you've
one
illustrated
measurement, right?
really well, Crit, is that this data is definitely open to interpretation, and that
Not only, oh sorry,
you have to apply a second layer of analysis in order to even make sense of what you're seeing here.
But take his question that you just asked about measuring a room. If you were measuring a room and you wanted to get it down to the, let's say you wanted to get down to the nanometer, which you're not going to be able to, but you're going to want to measure it as many times as you can and get as precise measurements as you can, because any single measurement that you make is going to have a little bit of error in it, because you don't have the precision to make the the precise measurement. So you make these measurements, and then you just take the average of that, and you'll get as close as you can to the precision that you're attempting to get.
Yes,
Yeah, my point is like that is just the internal error in the device. I'm not saying that this is the reason. I want to know, according to the manufacturer, how does temperature and pressure affect how this interferometer works? I honestly do not know, right? I'm not saying it should invalidate it. I'm not saying it should explain it. But what I do see in the data is that it correlates with it. The question is, why?
It's been fully studied, I will say, under the Silvertooth effect. Silvertooth was an etherite who actually argued against Einstein, used an interferometer, spinning it, and claimed to have detected ether. And he went all hog with it. Obviously, mainstream science kicked him back down and in favor of Einstein. However, later it was discovered or replicated just to double check, and it was found that it was temperature, is a temperature effect. So it's well known.
So yeah, I didn't say that we didn't.
He's well
I'm
within
saying,
the area
how
of the
does it
instrument.
work with this particular piece of equipment, right? I want to know its effect with this equipment and how it's used with this equipment.
So what you're looking at here is after Black Swan, Mr. Sensible said,
Can I give him a suggestion? Listen, go look up interferometer and dead reckoning. The purpose of any of the gyroscopic instruments or interferometer is to keep rigidity in space. And it's used in navigation to keep straight lines. So just go look at that, okay?
So we're well within the reference of, well within the error of this instrument, 14.05 degrees, right?
Yeah, for the average, but when you're looking at all the data sets, you're getting information that is well outside. Like the one showing almost 20.
So
right?
my question to the
18.
flat Earth is: if this is such a great disproof of the globe, why is it not 0? Why is it 14.05?
Yeah, all flat Earth models have the sky moving. Could you show me a flat Earth model where the sky doesn't move?
Well, I mean, is why would something on the ground detect the sky moving?
I think
so. What you're looking at here, at the end of the day, with all things considered, is that when Black Swan came out, Mr. Sensible said the best QE did here was disprove the radius value. And now in 2021, the best thing Bob did at the end of the day is he disproved 15.04.
No, he hasn't.
No, he hasn't. He's well within the area of the instrument.
Well outside.
Do we know
look
if
at the
Bob
purple
did-
area?
Did-
Everything
with these
outside of the
thi-
purple.
with
Yeah,
these
hold on.
things-
I'm almost there. Okay. Everything outside of the purple is a solid debunk. Something else is going on.
No, probably the instrument is solid calibration or something.
With
But it
these
came within
instruments-
14. So my question again is, why is it not 0? If this is the proof of the flat Earth, why is it not
We've been
0?
talking about that all episode. Have you been here?
Yeah.
No, I guess no. I'm sorry, I had to
Okay,
work.
Yeah.
This
So
is how- okay,
give me
there
the
is no-
Reader's Digest version then
Show
of why
me a
it's not
flat
0.
Earth model that has nothing moving, and then you'll know why.
Why is the globe, when you're sitting on the Earth, why and it detects when it moves, not when the sky moves? It detects when it moves. Why is it?
That's the contention, that it's
I mean,
not
like
detecting.
that's what I asked Bob that in 18 different ways, such as saying, does a voltmeter measure temperature? No, it freaking measures volts. Does an interferometer with the, that measures angular displacement, does it measure ether? Like, how are we jumping from I see something that measures angular displacement, I put it on the ground, it gets angularly displaced, to, oh no, the ether exists.
This measures a displacement of something, right?
No, it measures an
movement of
angular
something.
displacement. That's what you freaking calibrate the thing to.
Yeah,
Why would I
when-
say again?
it
Why
moves,
would I look
yes.
at it? Why would I look at a thermometer and say, "Look, it's measuring the voltage"?
If you pick it up and you go, because I heard you talking about this earlier. So let's say I have it on my test rack, and I say I'm going to move the test rack, and I'm gonna show that this thing is moving, and that's why it's recording something. So I move it. It's also moving in relation to everything else it's correlated with. So let's say it is the sun, some energy coming off the sun, or the ether that's traveling around the earth, or something else that's traveling around at 15 degrees an hour. I'm moving in relation to that. So in that point, I'd be calibrating it to whatever is moving at 15 degrees an hour that it's interacting with.
But okay, so if I'm holding it in my hand, okay, and I turn it 90 degrees and I see the thing registers 90 degrees, okay, I now know it measures angular displacement.
I now know that it measures angular displacement in relation to something, in relation to the zero that I put it in.
In relation to what I just exactly, that's called calibration.
Yeah, you're
Again,
calibrating
you
in
calibrate
relation to something.
Zero. It's zero.
You're calibrating it in relation to something. You're trying to tie it to the Earth rotation. Then you set it down and you go,
I didn't calibrate
okay, now
it
it's
into the
moving.
rotation.
Now it's moving again. That must mean that it is moving, but it could be the thing that is moving in relation to it, and that's what it's measuring.
That's not how it works.
What is this stuff?
That's what you say.
What is this stuff? Well, no, what is this?
We
this
talked
magical...
about that for hours. I don't know what
I'm
it
sorry,
is.
I
I'm not a
didn't like
proponent
it.
of any
The people who
theory in
designed
regards to this. I don't know
You're
nothing.
in theory, except that the Earth is spinning, the easy one, the one that's actually happening, right?
And the one that
I'm not a
devises
proponent
you
of the
don't
Earth
know, can you
spinning.
let
No.
people talk that do?
So
yeah,
what I was simply saying is that I do not put if I have a liquid that I know is exactly 0 degrees Celsius, okay, and I put it in there and my thermometer reads 0. I'm like, okay, it is reading 0 correctly. Then I take another liquid and it's 15 degrees Celsius and I put my thermometer in there and it's exactly 15. I say, okay, the thing has been calibrated for temperature. Great. If I then put it in another liquid and it reads 25, why do I then say, you know what? This liquid has a 4-volt charge.
It's not a good analogy.
I got
It's not a good analogy.
Not
Yeah,
a good analogy, right? Thank you.
I got this. I can answer
Do
it.
this with the accelerometer, okay? I turn it 90. I
already
zero
responded
it
to
out.
this one.
Okay,
You must
I
have
got
not
it.
understood my response.
I'm tracking.
Zero it out.
RC,
You put it
you already
at
went
0,
through this.
and
I already
changed it
responded to
45
it. Did you not understand my response?
There is one crucial of calibration.
I'm still in the middle of my.
No, you
But
said
you're
exactly
repeating
10
yourself,
three
though.
times in a row.
No. And now if I turn it 90 degrees,
Yeah, you want to move.
displace at 90 degrees, and then displace at 60, and then displace at 40, I know that angular displacement is what is actually doing. Why then do you
But
put it
you're
on the ground? and
assuming
say,
what
"Hold
is
up, hold up."
causing it.
Why then do you put it on the ground and say it's now reading angular displacement of 15 degrees, and you say ether?
Take a shot at answering, because my answer obviously didn't cut it.
So like Black Swan,
It was
right?
good.
The model claimed that the radius is 3959. Now the Earth still could be curved. It just isn't 3959. It's something more than, much more than. Okay. Now with thanks Bob, he falsified that the Earth is rotating at 15.04.
No, he didn't, because he didn't calibrate. There's a way to calibrate these things. You have to keep them stationary, I believe, for about 20 minutes at particular latitudes. I think if you're on the equator, it has to be kept absolutely stationary for about 25 or 30 minutes, up to 30 minutes, something like that, for them to get themselves calibrated. And
That's
so
a
that's
different
why
argument.
planes have to... Can I just finish?
That's
So
a different
planes
argument.
have to... God, Jesus, can I just finish the point? So when planes
Go on, miss.
switch them on, they have to remain stationary for 20 minutes in one location before they can then use them. And I suspect what's happened is that Bob didn't do that. and he just switched them on and then started moving around.
What evidence do you have of that?
All right,
What
stop.
evidence
You're
do you
getting
have
right,
of that?
wait,
The
wait.
way
This is
they work.
assumption.
So you're just making
Exactly.
shit
You
up.
suspect that
No,
Bob
that's the
did
way they
this.
work. You just don't
Suspected.
know just because you're ignorant
But
about
you
it.
wait,
That's
wait,
your problem, not
Nobody
ours.
said that. Rumpus, stop that. You're assuming that Bob didn't do that without even clarifying that
Right,
shit. And that's
I
exactly
was
why I
going to
can't
ask.
stand a
My
Glober.
next question was
Stop
going to
talking
be,
shit if you don't know.
my next question was going to be, did he leave it stationary or follow? Does he know the full procedure for setting it to 0? That's what I was going to hope to quiz him about. If he did, then fine. But there's an area there of possible problem.
Yeah, there could
See,
be
I would
lots of
assume
problems.
that if it came with instructions,
Yeah,
Rumpus, I assume that if it came with instructions, he read them.
This is the thing
You
too.
can
like-
assume what you like, and I'm assuming he didn't.
And
How
so
about
can
that?
you.
You're
She's just
assuming
calling you out
exactly.
for it.
So, no, I'm just raising the issue of you do have to do things with it, and I suspect, well, given the Bob's a bit of an idiot, that he won't have done it properly.
All right.
Have you ever put your
Rumpus.
hands on one of those things, Rumpus?
Yeah, if you want to do that and throughout the whole thing.
Hold on, Rumpus. Have you ever put your hands on one of those things?
He's gone, SE. Fuck him. And
Yeah, of course he's
Good,
gone.
man.
By the way,
Look, they want to say, oh,
about
it's
the
measuring the
gyro?
rotation, but not the
Hold on.
movement around the sun.
I'm right here.
Globebusters said,
Hey,
I
Tony,
did,
I wanna
and
ask
we
RC
did.
a
He
question
said
that-
he did. Just let me clear this up. Bob says that he did do the calibration. Of course, they did the fucking calibration.
Great. Okay. So if he did the
Thank you.
calibration, all right, let's just say he did. Cool beans. All right. Did he calibrate the thing for angular displacement or for ether drift?
Either way, if he did it for the Earth moving, it just falsified the 15.04.
Yeah, Tony. Hey, let me ask Tony a question. Tony,
Your
you want
model's
it to
done.
measure the Earth's rotation, but you don't want it moving around the sun. You don't want to. You say, oh, it can't do that because there's no ether, but all of a sudden it's measuring the Earth's rotation, but not the rotation around the sun. You want everything. You want your cake, your pie, and eat it and all that shit, dude. You just don't think, man. You just say any dumb shit. Do you want it to be?
I got a
so?
couple questions for RC on the gyro, and I'm not gonna. If whenever you guys are ready, let me know. I'll ask.
Yeah, I just got one more thing because even if the Earth is still rotating, it's not rotating at 15.04. And if it doesn't rotate at 15.04, the whole model is completely done.
No,
It's
you measured
completely
you
done.
measured 14. You measured 14 on an instrument that anything from 13 to 17 would be good.
No, there's much more. If you look at the data points, there's much more than just that. That was the average.
There's much more.
That was a weighted average.
Yeah. So
Yeah.
From 14
Your
to
average
20.
is within the error of instrument within 1 degree of a 2 degree. So anything from 13 to 17 would be a good result and prove that the Earth is rotating.
That's
like
how
you
you
said.
take measurements.
Isn't there more than that,
That's how
by
it
the
is.
way?
You came up with
sorry,
13 to 17. That's your instrument.
When you have
You got
thousands
18.
I'm sorry,
20.
I don't know if you've ever worked in data science, but if you have thousands of points of data, you do not just take an outlier and then start drawing your conclusions based on that outlier.
It's not
That's
one
the-
outlier. These are thousands of
It's an
outliers.
anomaly, and it's more than one.
There's full data sets that are
Okay,
completely
so
outside
if
the
you
outlier.
have if you have
Look at the-
5%,
Well, why is that?
if you can show me that more than 5% of those readings, okay, within the time frames of him not moving it, were actually not within this calibrated difference that we were talking about, then okay, cool. Let's have that conversation then.
Yeah, hear
but they're
this.
not. I have the data right here. It's not that much. It's less than 2%.
No, it's more. It's way more. Look at the blue circle. Most of the blue circle data set is outside of the tolerance.
Yeah, I have no clue. I have no clue what he was doing with that blue circle one, but that thing was not stationary on the ground when he.
And look at the red X.
It could have been.
How did you come to that
That's an
conclusion?
assumption again, exactly, that you say it wasn't stationary on the ground. Please don't make claims that you do
I'm
not
saying
know.
with the blue one in particular, I can show you a couple of
Right.
instances at the beginning, especially where I can see it was moved or knocked.
Well, no, I think I see what's happening here now. Based on that's why it would be nice to hear more from Rumpus if he has more to say, just because he shed some light onto something that you can also glean from this data, which is first of all, that blue one was the only one done at that location, and it was done. And so what Rumpus had said about the calibration and the time needed to calibrate, if you look at the you have the blue one, then you have the different circles, and you have the different X's. and they're done in successive order, about 30 minutes apart, 20 to 30 minutes apart. As they progress in a single line, so the circle ones, as they progress in time, they get closer and closer from being these further from the 15 degrees or whatever. And the only one that doesn't do that is, of course, the blue one, which stays up there because it's one by itself. But as you go from the orange to the green, they get closer to the 15.
And also below, you got to look at the numbers below too.
Okay.
It's plus or minus 2
Coach
degrees. So you got to look at everything below 13. There's 3 full data sets. That means 40% of the data is outside the tolerance.
Yeah, but you notice those ones are done right as soon as you got there. So there's no. It's very possible.
Okay, but is the blue at a higher altitude at the same latitude? Is it?
Yeah, the blue one was done outside on Pikes Peak, as he'd said, at 14,000 feet.
Okay. So you're talking about there's something there that you got to put into the equation. That's why you're getting different results, and that's what he said. So you're leaving that out of the whole thing here.
So you're telling
if it's measuring the inertial force from the stars, the luminaries, the sun, and all that, we would expect a faster, more degrees the higher we went.
Yeah, good point, Brian. Let me say something about what.
Exactly. I was saying that earlier. The higher you get up, you're gonna start measuring the sky more. So what the hell are you talking about? This proves his ether more.
Good point. Now let me say something about what Brian just said, because maybe this has been ruled out that this interacts with this device, but gravimeters supposedly pick up the sun and the moon. You can measure, you can supposedly calculate where the sun and the moon are based on the data that you get out of a gravimeter. So the idea has been scoffed at that the luminaries could be affecting this device somehow. I don't understand why.
Because they have
massive issues with it.
They have nothing to do with the gyro and how it processes.
I don't see why it couldn't be electromagnetic.
There's massive issues with it. Hold on. Why? Holding on. Why not?
Yeah, go ahead, Jeremy.
I mean, there's massive issues with the gravimeter. That's all I wanted to say.
Well, yeah, that's fine. But the biggest difference between the two
it could be
things-
electromagnetic.
Was that a joke, Jeremy?
Mean that that's what gravity is, but it doesn't mean it isn't.
No.
Keep open mind. I keep open mind for everything. I recommend y'all do the same. Y'all just so locked in. It's got to be this. It's got to be that.
It's fine to keep open-minded.
And you guys are speculating. This is what bothers me, Kosho. You guys are speculating about he must have been doing this during the data set. Oh, Rumpus, he probably didn't calibrate it. Oh, somebody bumped it. A fly landed on. What the fuck is the point of all this?
Brennan, that's fine. But I'm talking about the thing you specifically said,
okay,
which people are bringing up. This is important to note: is that a gyroscope and the things it measures are not good. It's not going to pick up a car circling around it and do a rotation because of that. Because it doesn't. That's not how it works. It works by being moved itself. So the gravimeter doesn't work that way. It works by gravitational influence, which we know, at least in our model, that the sun and the moon have huge gravitational effects on the Earth in the form of tides. They create giant waves in the ocean. So it's like they would indeed affect the gravimeter. It's not going to affect a gyroscope because that's not how gyroscopes work. They don't work by things rotating around them. They work by itself being rotated.
That's your contention, yeah. But I've yet to see
that's how gyroscopes
solid
work.
evidence that that's the case. We're looking at this data.
So can
we
I
need
ask
more
a question
data
about
and
the
evidence.
Next time somebody interrupts Brandon, I'm muting him.
Yeah,
It's not a contention. It's the fact that is exactly what we see it measure. We cannot invoke something new when we've already shown it that this is the thing that it measures.
You don't see
Just
it
like I was
measure
saying earlier,
the Earth rotating RC.
Temperature. Hold up. You don't invoke that my voltmeter is measuring temperature when I've already shown it.
Again with this, third time. You are not measuring, you are not seeing this impacted by Earth rotation. You never seen Earth rotation in your entire life. You've never seen the Earth move in your entire life. You are seeing some data result from this, and you're tying it back to your model and saying it's this.
Brandon.
And then when you move it, which could be the same as moving it in relation to it, because that's relativity. That's your fucking bullshit relativity stuff. When you move something in relation to something, it's the same as moving that thing in relation to the other thing, right? That's all I'm saying.
Brandon, all I'm saying is that if you want to say that it's ether, I told you exactly what we can do. And I haven't had any Bob or anybody else tell me, how does the ether affect this instrument? And how do you know that it is? That's all I'm asking for.
Okay, here it is.
That's a fair question. I think we need more.
If I,
okay, RC, listen, I got this.
I was in the middle of my sentence. So if I say that it's going to measure angular displacement and I show that it does, and then I put it on the ground, I'm not trying to invoke anything. But if I look at the freaking instrument and it's showing angular displacement, then I'm going to say, all right, the Earth is being angularly displaced, aka it's rotating. Now, if it's not, and you want to tell me that it's ether, cool beans, show me how that it's ether.
Okay, it's not ether. It's Earth rotation, and it's not 15.04. Your
Bro, you
model's
didn't hear me,
destroyed.
man. You must not have heard me. Look,
Your
that thing
model's
is 10
done,
times
either way.
sensitive enough to measure the motion of Earth around the sun, yet it doesn't. So you want it to get the Earth's rotation, but you don't want it to pick up on the Earth's motion around the sun when it is 10 times, it has 10 times the sensitivity that it needs to detect that movement. You just want everything, bro.
That's an interesting point,
Yeah,
Brian. We'll have to explore that later, but I do want to give James a chance. He asked nicely. Go ahead, James. You wanted to ask some questions?
Yeah, I was just going to ask RC, and I asked it Monday night. I don't feel like it was answered, and if it was, I apologize. Just let me know, obviously. The Earth allegedly at the equator rotates roughly 1,040 mile an hour. And as you deviate from that, it slows down. So wouldn't the gyro pick that up?
The gyro is measuring angular. The tangential velocity and angular speed are not the same things.
Yeah.
So which one is
number
that?
one? A gyro does not measure anything to do with velocity. It only measures angular displacement, or as Jeremy actually said very correctly, if there's an angular speed associated with that, it can also detect that.
And the best.
So when it's that's my point though. So when it's detecting, let's say at the equator, 15 degrees per hour, right? That's at the equator where it moves the fastest. You saying it detects movement, the tool. It cannot, and it's 15 degrees per hour there, right? You get what, 24-hour sunlight in the North or South Pole? So you have
not all.
I know the argument. I know the argument. So the argument of the gyro is it picks up 15 degrees per hour, regardless of day or night. It's just day and night equal with the gyro, the 15 degrees per hour.
Yep.
My point is why? How is it detecting the 15 degrees per hour, which is a speed at the equator?
That is not a speed at the equator.
No. James.
Well, it's picking up movement, and it's a speed.
Yeah, and that movement is 15 degrees per hour. The tangential speed at the equator would be around 1,000 miles an hour. The tangential speed, of another parallel will be 800. Doesn't matter. It's still 15 degrees per hour, and because the interferometer only measures things displaced angularly, that would be in degrees per hour. Nothing to do with a tangent.
I think I see. Okay. I think I understand.
All right.
Yeah, this is it. This is like
so let me give you a good example just so you understand that. If I put it on a merry-go-round that's going 1 revolution per minute, no matter whether I put it on the inside of the merry-go-round, which is only going maybe 1 mile an hour or something like that, versus on the outside where it's going 3 mile an hour, right? It's still going to measure 1 rotation per minute.
Okay, that was my only other question too.
So based on your idea.
Hold on, one more, and
idea.
I'll be quiet. My other one was kind of similar to that. When you put the gyro on the merry-go-round, and it gives you degree per minute or hour, however you want to do it. Do you have to deduct from that the Earth's rotation? Because isn't it still affecting the gyro?
So you can actually calibrate a lot of these gyros, and this is something that happens like in the G1000. Like I fly general aviation aircraft.
So the calibration zeroes it out, like weighing something. You want to weigh the.
Yeah, you can essentially Yeah, and in fact, I posted a link to the FAA of how you actually calibrate for things like Earth transport precession and gyroscopic precession in your instruments, and they use the exact same principle when they're using things like ring laser gyros or interferometers or any type of accelerometer on airplanes. Yeah.
Okay, go ahead, Data.
So on your understanding that if it's detecting Earth rotation, that if you had, let's say, it pointed at one direction, your interferometer was pointed north. According to your rotation, the Earth would rotate from that position 15 degrees, right?
It's only going to measure it on whatever axis it's set to.
So okay, so it doesn't matter if it's stationary in a position; it's going to measure rotation under your impression of the move.
Not under anything. It's simply whatever it's sitting on when it is
it's suspended. It's suspended in midair. We have it suspended in midair. Okay.
Why?
Well, because what a plane is, it's suspended in midair in an aircraft, right? So it's suspended in midair, and it's detecting Earth rotation, right?
Sure. You can.
Okay.
You want to calibrate it like that?
No, I'm understanding this is how you think about it. You're saying that it's detecting Earth rotation. So if it's suspended in midair, the Earth is rotating underneath this device, right?
No,
that's the only. It's not.
It's rotating. The atmosphere is rotating, so
it's the atmosphere that's rotating, and not Earth that's rotating.
Earth and the atmosphere are one celestial body.
Oh, so the Earth and the atmosphere is one celestial body.
Yes.
Okay. So you have a gyro suspended in midair. It's detecting the atmosphere and the Earth rotation.
It's not detecting anything with the atmosphere. It's simply detecting its angular displacement.
Okay, so it's not detecting anything, but it's detecting angular displacement.
I said
the
angular
displacement. Hold on.
Atmosphere.
Let me finish. Let me finish. Let me finish, please.
Incorrectly.
Okay, go ahead.
I said it's not detecting anything in the air. It's detecting.
I'm not saying it's detecting anything in the air. It's detecting, according to your model. No, I said it's in the air, suspended in the air, and it's detecting Earth rotation is what I said. You said no, it's not. It's detecting the angular displacement, which is caused by what?
Earth rotation.
Right. So it's detecting Earth rotation then.
Yes.
So it's not detecting angular. It's detecting Earth rotation.
The angular displacement.
Yeah.
The angular displacement. The angular displacement is
caused by
because
Earth
the Earth is
rotation.
rotating.
Right. So if it's rotating, right? If it's rotating, it's a physical movement that it's detecting, correct?
Yes.
Okay, so if it's suspended in the air, independent of the Earth rotation, that means the Earth, the angular momentum of the Earth is changing relative to the position in the air.
No, it's not independent of.
That's what a gyro is. The gyro is
Excuse me. The air is not independent of the Earth.
Let me finish. The gyro itself is independent of any acting force on it. That's why it makes it. Let me finish.
Oh, you're so wrong. My God.
Let me finish. Why are you jumping in? Don't white knight for him.
Yeah.
Chill out.
I'm not white knight for him. I'm just amazed at how stupid you are.
All right.
Okay, you're white knight,
Why do you
bro.
want to get
So
Keep quiet, Chills.
if you have a gyro in the air, the only way it can detect movement or angular displacement is by having its own rigidity in space, correct?
Yes.
Okay, so if it has its own rigidity in space and the Earth is rotating underneath it.
Nope, there's no underneath about it.
Oh, okay, so then how does it detect the rotation?
Because it is being angularly displaced.
So how is
it's
it
moving with the Earth's surface in this scenario? If you
Oh,
want to
so
make
the
a claim,
gyro-
if
the
you want to make
gyro-
a claim, I'm
Are
going
you
to
white
finish.
knighting too?
If you
Are you white
no,
knighting too?
no, because I had this conversation with you where you said the sun affects the gyro's readings. So I want to get in on this. If you want to make the claim that the gyro is suspended in the air and doesn't move with the Earth rotation, that's a totally separate story, and you're invoking magic to try to make a moot point.
I'm invoking magic to
you're
make
not,
a moot
you're not
point.
going to play games with
Okay,
me.
so hold on. Gentlemen, the purpose of a gyro is to create, or an interferometer.
We know what a gyro is. Why don't you ask your question and make your point?
No, you obviously
Y'all quit
don't
being
know what a
smart
gyro
ass. Even the
is.
pendulum during an eclipse, even the pendulum fucks up. Dude.
Brian,
He just
Brian.
ridiculed you,
Don't
dude,
act like
and
the
you
sun
don't
and moon
realize
don't
it.
do anything.
Okay, data on the plane, flat Earth data. go ahead and make your point so that we can actually have a conversation. Because you're about 30 questions in and it's boring.
Okay, so that's your argument?
No,
Actually, Data, I don't think it's boring at all, and I think you need to figure out. No, you're being rude.
I was talking.
I know you were, but please stop being rude.
The point is,
go ahead,
There
Data.
hasn't
Keep
been
it
30 questions.
Try to keep it concise, Data. Go ahead.
Excuse me. The point is that it is detecting angular displacement. The reason for this angular displacement is the fact that the Earth is rotating.
Right. So the gyro has to be independent of the Earth rotation to detect it, correct?
Its interferometer detects any angular displacement. Yes.
He won't answer.
No, the problem is that they
listen.
can't
If you go back and listen to the questions and how you responded, dude, you're done.
You destroyed him. He doesn't even realize it.
Let me say
you don't even know how a
There's
gyroscope
nothing that's
works,
destroyed
dude.
about this. The fact that you do want to deny the fact that the Earth is rotating.
Okay, let me say something real quick. Let me say something. If you don't interrupt me, y'all.
I'm in the middle of a sentence.
Okay,
dude, you interrupted him everything he said, dude. Now look, so the ring laser gyro or the interferometer.
I'll give you a chance, Brian. Hold on.
Brian.
Okay.
So the fact that you don't want the Earth to be rotating and the fact that the gyroscope does indeed detect an angular displacement has nothing to do with the fact that you don't want it to be doing that.
Why are you divining our thoughts? I actually want the Earth to be rotating on a spherical object.
Why are you?
Can you
I don't know about
please
the rest of
explain
you
what
guys.
rigidity in space means, please? What's the main principle of the gyroscope? Please explain to us.
The main purpose of the gyroscope is to ensure any type of angular displacement on any given axis is measured.
Can I get an angular displacement by banking left or right in my aircraft?
If you have it on its lateral axis, yes.
Awesome, buddy. Thank you. So it's not Earth rotation that can cause displacement.
Hey, let me shut him down real quick. Hey, so you say the ring laser gyro and the interferometer, they're using light, okay, to measure angular movement, basically, angular momentum. Basically, you're calling it the Earth rotation. But okay, so then you say the Foucault pendulum uses a physical pendulum going back and forth to measure the Earth's rotation. Yeah, and you say that the sun and the moon or the ether, whatever you want to say, is not affecting the ring laser gyro. Okay, but we know that on an eclipse, the Foucault pendulum does funky things and never cooperates on a lunar on solar or lunar eclipse. And so the point is, you don't know, dude. You don't know what the ether or what the sun, what the moon, any of that's what could be doing with the light. Okay.
Judging
like
by
you don't
that,
know what the sun and the moon are doing to the Foucault pendulum, but y'all, even with problems, y'all still attribute it to Earth rotation. Why would the sun?
Judging by the incoherence of your statement, it's not me who doesn't understand something or doesn't know something right now.
Why, Brian, you brought something up, I don't know this for a fact, but you said that pendulums are affected by, eclipses?
Yeah.
Yeah, he's tripping balls.
From Foucault himself. He'll say,
it's called the Atlas.
Full of shit, dude. He'll say, I'm going to make a video. He'll just say anything to keep his model, dude. He's a condescending.
It's called the Atlas effect with the Foucault pendulum. Remember we talked about this?
Yeah, that's right. And those people got kind of like laughed out of science, right? It was real controversial because it didn't fit the model. Has anybody tried an experiment like that? No.
This has been really great because, like,
what'd you say, Brandon?
Has anybody tried an experiment like that? This Atlas effect?
Yeah, he himself tried it again, and he didn't find it the second time or ever again.
Well, what I read before was it had been repeated with success and mixed results, and no one knew how to interpret it. If I remember correctly, I'm looking for it again, but it's not coming up when I search for Atlas effect.
Yeah, I think it's ATLIAS.
Oh, that's
right. Sure.
Effects from stuff in motion, especially circular motion. Like that's what I was talking about when they were talking about dropping the weight from the Eiffel Tower and measuring it. They had to discard that experiment because they cherry picked and got the ones that they dropped that did what they wanted to. But if you just drop something, it's gonna knuckleball. Like if you throw something like a ball and it's spinning, it's going to curve one way or another depending on which way it's spinning. Same thing with a
Yes,
bullet.
that's the Magnus effect.
And if you throw a ball forward and it's not spinning at all, it goes whatever direction it wants. It might go in a certain direction more, but they call it a knuckleball in pitching in baseball. And that's what happened basically. That's the only effect they got was knuckleball shit, and that's why it was inconsistent.
It's called the Magnus.
Yeah.
It's called the Magnus effect.
spin.
Think of the
The
alias
spinning
effect,
thing.
the Atlas effect.
That's what I meant, alias.
Not to move off on a tangent, but knuckleballs don't spin. That's why they're random, because there's no set rotation to it.
Oh, that's right. It's the Elias effect, right?
That's what I meant. That's what I meant, man. When they dropped them weights, they weren't spinning. When they dropped them off the Eiffel Tower, they weren't spinning. So they acted like knuckleballs. That's what I'm saying, and that's why they got such inconsistency, because there's no way to predict which way a knuckleball is going to go.
Right. Okay. Then I misinterpreted
when they dropped the object. It wasn't spinning. You see what I'm saying?
Right. No. I get what you're saying. I misinterpreted it the first time.
Yo, if anyone has a building or some area where we can let Bob use to drop these magnets or whatever he wanted to do, let us know. Also, BioDuel, welcome. You're going to be the first person on QE's numpty clips that he's putting out on the Quantum Eraser channel. Go YouTube that. They're very good.
Yeah, that's fantastic, Jeremy. I already get my dick sucked by Chemo in the other channel. I don't want to get my dick
I was
sucked
just giving QE a shout out, bro.
I really don't want to hear what you do sexually, but thank you.
No, I'm saying I
So
don't.
when you calibrate a gyro,
shit.
Are you doing it based off the fact the gyro is motionless?
No, you're doing it at the fact that when you turn the thing 45 degrees, it registers 45 degrees. And then when you turn it 90, it registers 90. Then when you turn it 42, it measures 42.
And when you measure the Earth, you don't get 15.
Right, but you're...
Yeah, what he's asking is, are you measuring its effect in this context specifically of the Earth rotation because it's stationary? And the answer is yes. In this situation, because you're trying to measure if the entirety of the frame that it's in, like the Earth, is the thing rotating, you want to isolate it from other movement, so you keep it still.
Hey, let me read something, and maybe you guys can tell me if this has anything to do with this Elias effect being controversial. Erwin Saxel and Mildred Allen similarly reported strong anomalous changes in the period of a torsion pendulum during the solar eclipse in 1970 and concluded that gravitational theory needs to be modified.
Yeah, so I'm saying that's part of the alias effect. He's got some weird results one time, and claims he got it a second time, but nobody saw the second time. Regardless, so he came to conclusions based on that. But usually, what you do when that happens is you recreate it and make sure that that's indeed, a different result and not just some flaw in something that you did, and it hasn't been successfully redone by people.
Crazy that you want to check your work.
I'm confused a little bit still, guys. I apologize. When you calibrate the gyro, you said yes, you do it as if it's motionless, but you're not.
When I say calibrate the gyro, I'm not just meaning its angular displacement. Okay, you have to zero the thing out, and then you have to move
what? Like, what is your zeros? Just
whatever,
zero?
wherever you place the zero on its axis, right? So you define its rigidity, okay, at the zero. So you can just lay it on your desk and then zero the thing out, so that it will then measure in radians or in degrees per hour, like however you want it to actually measure it. Okay, you zero it out, and then you turn it its number of degrees that you want to turn it to. Then check. Okay, it did it in the time that it said it was going to, and at the angle that it says it just moved at.
Yeah, you could program that thing to spin any amount, man. I mean, to deviate any direction. It's
not a program.
You just got to calibrate it that way.
Doesn't matter. You would be you could also be moving it in relation to whatever it's detecting. So
that's where I was going, Brian. Was reaffirming the consequence. So you could calibrate it in, like Brian said,
there's no
affirming
consequence.
Hold on.
Formal
and call
logic.
that zero.
Whoa, RC. It actually is an affirming.
You could call that zero.
It's not. It's not a reaffirming
Q all day.
fallacy.
If you
we're not doing
calibrate it
that,
as if
we're
it's
measuring
motionless and
something.
you're not, then
You're
you didn't
measuring
calibrate
something.
No.
it as if it was motion.
And you double checked what exactly you're measuring. You're measuring angular displacement.
If the Earth is a spinning ball, I will see this effect. I see this effect, therefore Earth is a spinning ball. That is all day long. That fallacy.
Did you hear anyone? Hey, hold up. That's a straw man. Did you hear anyone say that?
I restated it, didn't
Yeah.
I?
Oh, that's
paraphrased
not
what you're
actually- No, no.
saying. Yes.
So it's not, that's not what anyone said, so you're making a straw man.
No,
What
it's
I
not a
said
straw
is-
man. That's essentially what you're telling us.
What I said is, I have an instrument here that measures angular displacement.
Oh, okay.
Oh, goodness.
If you use those
And
words,
I-
then
I put
obviously I'm straw man.
but it's basically.
I put the instrument on the Earth, and it measured angular displacement.
Oh, give me
Why-
a break.
why
If
does
you
it
say
not be
angular
lateral?
displacement over and over and over again, do you think it makes it more
Angular
official?
displacement is based off a horizontal, right?
No, because you can turn it 90 degrees before you calibrate it. Then you can calibrate it.
Yeah, that's
And
what
when
Brian
you-
was saying. You can call anything zero
Right,
to
but-
fit your narrative.
But you can't calibrate it while you're. Well, I guess you could, but you get shitty readings afterwards.
You could. You
want it-
absolutely
want it-
What data said should have shut him down anyway? What data said proved it? Like right there. If you're in a plane and you recalibrate it, and I mean he had him double speaking, man.
No, you're not
I don't know
supposed to
about
you're not supposed to recalibrate it while you're flying. All these tests are done on the ground, and if you're
No, that wasn't the point. The point is, you say is the ground moving or is the object moving?
Hold on.
But I am gonna.
Hold on, guys.
If you have to
Go ahead.
calibrate it while on the ground, and if,
horizontal.
Guys, let Bio
While-
finish, please.
while you're on the ground, you calibrate it. If you can't calibrate it and it's giving you shitty readings and it's fucked up, you don't fly. That's how serious it would be within a plane. So you're not, if it fucks up in the air, you're going to come down and land. You're not going to continue flying. You can't calibrate it again.
In fact, I can tell you exactly what we do in an AHAR system. I just posted an AHRS, okay, on an AHAR system. And if you see an AHAR system failure, you get the F down, right? And in fact, why we keep a vacuum-driven mechanical gyro in the airplane, at least on the brand new Cessna 172 SPs. That's why we keep a mechanical one in there in case our AHAR system fails. Then we have a backup.
Right. Same in the military. They have attitude indicators that are separate from this gyro.
That's
Just in-
fantastic.
just in case.
You guys can go, talk about that all night. But Illegal has something
What
that
are
he
you-
wants
what are you
to
talking
talk
about, man?
about.
Like, this is
You
literally-
guys are
it's
just
something we literally
jerking
use
each other
every day.
off over this shit. Go ahead, Illegal.
Yeah, thank you, Brandon. Yeah, this is real simple. We can argue about gyros and that all day, but let's beg the question and say the gyro does prove Earth spin 15 degrees an hour, okay? So the Earth is spinning at 15 degrees an hour. You would agree that like the Earth turns under sniper bullets, correct?
Depends on which day you ask some
Earth
of these Globers.
Earth doesn't turn under anything because the reference frame is not the atmosphere versus the ground. The reference frame is center from axial rotation, which would be from north to south.
Oh my God.
Oh.
Okay, so we're gonna have to
Yeah,
go
how
through
come
the whole Coriolis effect thing just to make my point. Like,
Yeah, your Coriolis, your reference frames are completely wrong. It is not the ground versus the atmosphere. It is how you are traveling through the atmosphere from north to south.
Illegal, we'll understand your point, and we won't make you go down this whole big thing into Coriolis. Why don't you just make
One
your
last
point to
thing,
us?
Brandon.
Hold on,
One last
Brian.
thing.
Hold on, Brian. Go ahead, Illegal. Finish up.
okay, so the contention is it's the gyroscope is saying something is turning, but the contention is what is turning. They say it's the Earth turning. So if the Earth is turning, 15 degrees an hour, then it will rotate underneath anything that leaves the non-inertial reference frame. So if the Earth turns, it's going to turn under if it turns under sniper bullets like they claim and other things, then it would turn under airplanes and drones and hot air balloons, and it doesn't do that. So
No, because you are trying to create the false claim that the reference frames are the atmosphere and the Earth. That is not what the reference frames are. It's center from axial rotation, just like on a merry-go-round going from the inside to the outside. On Earth, on a 3D object, it would be going from north to south.
You said Mario go around. I'm
How
totally
convenient,
fucking triggered now. But I want to say something. Earlier, you guys said that we were invoking magic. You guys invoke magic all the fucking time with your magic atmosphere, the earth that moves perpetual motion around the sun, all this perfect working order shit that just happened from something that exploded from nothing, right?
Magic.
Magic.
No.
Yeah, let me
Yours
make-
is
I don't
all
agree.
magic,
You
a
claim to
force
say
we
that
can't
are
block
giving
or
him the,
harness that controls everything in the known world.
I don't agree to
RC
most of
when,
what you stated, by the way.
Anyway,
Hey,
we're
the
gonna
same
do final
device that's
thoughts.
supposedly measuring their Earth rotation does not measure Earth curve in a plane. Like the interferometers or the little sim devices in our phone. You're saying that they measure Earth rotation and interferometers, but in a plane they don't show the ground curving away from us straight ahead. You want everything, man.
We don't have
It does
interferometers.
with the deviation between the horizon and your eye level using the heads-up display unit. As you increase,
Don't get started with the
That's,
horizon.
that's the easiest one in the world. Have you guys ever seen a hood?
Hey guys, we're gonna go into final thoughts. I'm sure you guys you can pick this up where we leave off, but it's almost 8 o'clock right now. Let's just go quick. Just say a couple sentences or so, and we'll move on. Percentage. Bandsaw.
Yeah, great show, mate. Great show.
Thank you, sir. Biodual.
Thanks, Bob.
Brian Leakey.
Yeah, man, good show. And I'm gonna just say they don't know Earth spin or whatever the hell it is, man. They don't know. It's never been proven. End of subject. Thank you.
Thanks, Brian. Car in Kentucky.
Hey, enjoyed the show.
Thank you, sir. Crit.
Yeah, don't let them get off this, okay? Thanks, Bob. He falsified 15.04. If they want to give them that this is measuring Earth curve, they need a new model. Just like they need a new model for Black Swan when they got falsified 3959. They're going to regret. They regretted the day they said that was Earth curve that ships were disappearing under or over, bottom up, and now they're regretting the day that they said the Earth rotates at 15.04.
Thanks, Crit. C4.
Thanks, man. Good show.
Thank you. Gleam. Global.
Oh, sorry, my man. I was muted up and I was quickly trying to switch windows. Very, very quickly. I'd just like to respond to the RC thing of the voltage. If I measure voltage or if I measure temperature, well, if I put it back at you, Einstein said that within a lift with no windows, you could be falling at 9.8 meters per second or in space, and your accelerometer, your meter, would measure the same thing. So there's two different interpretations, which is the same thing. And you're just saying, no, I can only be falling. I can't be in space floating.
Thanks, Gleam.
Thank you very much. Cheers. Salute.
Thank you, sir. Thanks for stopping in. Global.
Bye.
Jeremy.
Yo, shouts out to QE. Those numpty clips are fucking hilarious. If you don't watch them, you're fucking up. Shouts out to Chemo. And good shit for the data, Bob. And have a good night, guys.
How much QE pay you to give shout outs on here? Tell me the truth.
Yo, this shit is good, man. They're fucking hilarious. I'm telling you, check those numpty clips, man. You'll see all the double speak that the Globers do. He points out all the bullshit, the fallacies, everything.
All right. Thanks, Jeremy. Illegal.
Yeah, shout out to QE Numpty Clips.
Oh, shit.
Hilarious. I got paid nothing, unfortunately, for that. Yeah, but no, I'm gonna try and make this real quick, just in response to RC Meisty. He must disagree with Neil Smoking the Grass Tyson and with the Earth rotating underneath the football, causing the field goal to be made. So if, like I said, if the gyro is saying that the Earth is turning, and Neil deGrasse Tyson says the Earth turns under footballs, leaving the non-inertial reference frame, then it would turn under airplanes and drones and other things, and we don't see that. So that would lead us to believe that it's not the Earth that's rotating, it's something else that's rotating. Okay, thank you.
Thanks, Illegal. James. James Richard. Jedi.
Oh, sorry, guys. Great show. Even though I disagree with RC, he seems to be very cordial and polite. I'll just say that.
Thanks, James. Jedi.
Yeah, great show, Brandon. Really glad that Bob came on. I just want to give a quick shout out to RC Marsty as well. Great to see you, buddy. Yeah, great show, mate. Really appreciate it.
Thanks, Jedi. George. Show.
Yeah, don't have anything particularly interesting. I did think it was a good show. I did think that that any chance that we get to talk to Bob about this test really should be spent primarily on trying our best to retrieve as much information about this test, about his data as possible. Because the more information that we get, the less questions that we can have and less assumptions that we'll be making when we do determine it. I do think that I do think we can make we can come to conclusions based on what he's found, but I think the more information is better. And I really actually would hope that in the future, more flat earthers, more anybody really, anybody involved in this community, for them to do tests like this, and also to scrutinize the test the same way we are right now, to try to try to come to conclusions based on the information and not on what we want the conclusions to be.
Thanks, Kosho. Left lane.
Hey, Brandon, it was a good show. You got a good handle on it. The thing that I said earlier about people saying that Earth is spinning underneath things, that's really a straw man. Nobody that knows Coriolis says that, and Earth is not spinning under things. But and one more thing, if you want to measure the ether, build an ether detection device, and I'll take a look at it. That's all I got, buddy. Thanks.
Thank you. Matrix.
If Globers were to scrutinize their own stories, just like they want to scrutinize every flat earther, they will all be flat earthers. Thank you, Brandon, for having me. A good show.
Thank you, Matrix. Page. RC.
Absolutely excellent show, Brandon. You got a really special place here. I really enjoyed the fact that we actually had dialogue today. That's a really refreshing thing. Shout out to my flat earth friends. Even though I disagree with you, I really appreciate that we actually spoke. But yeah, show me how you measure ether, and then we can talk about invoking ether to understand Bob's measurements.
Oh yeah, appreciate that, RC. Rob.
Okay, can you hear me?
Yes.
I got a shit mic. Okay. All I want to say is I think we all glossed over something else that Brian said. So this ring or fiber optic gyro is supposed to measure 15 degrees of Earth turn. But what about the Earth traveling around the sun and all the other motions in so-called space that are happening with the Earth when we feel nothing? Thanks, Brandon. I love this show.
Thanks, Rob. Appreciate it, man. Sorry I was a little hard on you earlier. Sirok.
Ah, cool, bro. Don't worry about it. I shouldn't have jumped in.
Sirok.
Hey, Brandon. Thanks for letting me listen. I got nothing right now. Thanks.
Anytime. Thanks, man. Seek and find.
Yeah, just want to say thanks. Thanks, Brandon, and everybody. Hit the like button, man. Good stuff here.
Oh, yeah. Thank you. SE.
Yes, sir, Brandon. Great show. Wow, the Bob proved. Got to give a shout out to Bob because, first of all, let me just say that the Earth is not spinning. Let's make that clear. Now, in their own fantasy model, the Earth spins at a constant rate. Now, what Bob showed today, his data, which he gracefully shared with us, is that we have deviation from 14 to 20 degrees. Oh boy, we have a problem here. That's all I wanted to say. Thank you, Brandon. Great show.
Thanks, SE. Silent Zero. Snake Oil Con Man. Stacy B.
Hi, Brandon. Thank you, everybody. That was actually really nice and respectful because tonight was a better show for me than the other night. I want to say thank you to Bob for coming here and showing your face after everything that he went through, because I know what that feels like. And one, do not forget, at the end of the day, yes, we have some data and we may have some information, but we still are making assumptions and we don't have validation. So until we do more testing and we get there and we're speculating, which is wonderful for us as flat earthers, because I don't want to be an echo chamber. And we need to find out what's going on. We all care about finding that truth. So there's nothing wrong with Bob doing these tests. And I hope more people on both sides want to do something, because at least Bob, like a lot of other ones that need to be doing stuff, is actually doing something, like someone said earlier. And that's important. We're not sitting behind a keyboard and talking all day. We're actually trying to prove what we're standing on. So shout out to Bob for even trying to do something. But at the same time, we're making a lot of assumptions. And let's not forget, it's about validation. So right now, there is still no proof of a globe. And until we have that, we've already won. But thank you.
Hell yeah. Thanks, Stacy. Bob. Bob Dole. No? Okay. My final thoughts. Thank you to the panel. You guys are the ones that make the show good. And it was especially good. Shout out to Bob for coming in. Appreciate the data. Very good stuff. Thank you very much. And we'll be back tomorrow night. And who knows what we'll be talking about. If anybody has a chance between now and then to look further into this data and see if there's any other variables that are in the data set that we can draw out, that would be awesome. If someone happens to create a CSV file out of the data and can post that in the chat, I can probably work with that myself. But that would be awesome. So anyway, thank you guys. I'll be back. I'll record an after show.
Hey, you there?
What?
Yes, sir.
Hey, question.
All right. Thanks, guys. Really appreciate it. Hope you guys enjoyed the show tonight. We'll be back tomorrow. And don't forget, Friday, George is going to come in and give a presentation in between our Friday night fights. And that's going to be related to, what the hell is that? Radio waves, and the ionosphere. He wants to directly address some things that were previously said on the show. So hopefully that will be interesting. He's put a lot of work into that. So we're going to give him the time to show us what he's got. So anyway, we'll talk to you tomorrow. Thanks to the mods in the chat, and thanks to everybody for watching the show. Have a good night. See you later.